the Safety Doc Podcast with author, radio host, and nationally recognized safety expert, Dr. David Perrodin. Join us each week as we discuss the best and most bizarre practices in safety preparation and crisis response. Follow Dr. Perrodin on Twitter at SafetyPhD. And remember, the truth will keep you safe.
Hey everybody, it is your good friend the Safety Doc from down here in the North Star recording studio, where it is a brisk 61 degrees this evening. So if you've got a jacket, put it on. If you've got gloves, a hat, boots, if you can start a small fire, a little buddy, anything going for you. Pull it out right now because it's chilly down here, but that makes it for brisk, spicy content. And you see my good friend flyingRich, and I'm going to introduce flyingRich in just a moment. It's my privilege to have flyingRich on the show. For those of you who watch the show and you're like, hey, why is there no show thumbnail? YouTube does that to me sometimes. They single out the doc and they're like, we're going to give you 3 gray dots, even though you've created a show thumbnail. It's kind of what we're going to do. So I am doing well. I want to thank everybody in the chat. We already have a great, robust discussion happening over here. Robert is saying, don't forget to like and subscribe to the Safety Doc. I appreciate that, Robert. And up above in the chat is the subscription. So 1,150 followers as of today, which is remarkable.
Nice.
Thank you. Yeah. So many people flying Rich, John Crump, DLD Live, Bacon, Maldito, so many people who came together in the last 3 months and basically helped double my channel subscriptions. So every morning I wake up and notice there's maybe 10 or 12 more people who have found the channel and subscribed. So I greatly appreciate that. Again, we do talk about school community safety and then have those kind of rigorous discussions of kind of what makes sense and what doesn't. And this show also couples to Fridays, Face Validity Fridays in the morning, where I go through 4 headlines and we work together and we're like, hey, does this make sense or does this not make sense? But today's show, so I was introduced to flyingRich through John Crump Live. And I started to watch some of Rich's shows about 3D printing. And one of the most incredible shows was he had his pool vac or vacuum cleaner for his pool to clean it out. And he redid some parts on that with his 3D printer because it was the device was failing, right? And then he got it to work again. He's showing it going through the pool. And as someone who lives in Wisconsin right now, my pool will be a skating rink because it is literally 3 degrees and it'll be -7 tonight. But I'm like, wow, we think of 3D print, not we, but I think a lot of people think of home 3D printing of, okay, you're going to make like a flute or you're going to make something that's, more of a novelty item. Yes, you can do that. And that maybe was 3D printing 10 years ago, but now it is much different than that. So Rich is going to tell us about some of the different things that he's printed or some of the things that he's seen. We're also going to talk about 3D printing in a disaster situation, whether it be like after the Kentucky tornadoes, after it be the fires that ravaged through like Superior, Colorado. What might be the future of rescue involving 3D printers? So first, let me introduce flyingRich, but first I'm going to welcome you to the show. flyingRich, welcome to the Safety Doc Podcast. So yeah, thanks. So you've got the whiteboard going in back of you. You got everything all set up, and shout out to a few people here in the chat. Ting Ting, MK Joe, Vanessa, Sandra Newton. Hey, I think Sandra Newton might be a bot. So those of you in here who are in bot control, including Robert, let me check my bot control. Vanessa's on bot control. Yeah, if you guys can get in there and kind of take care of those bots, weed them out, I would appreciate that greatly. So, and Bolo, so let's see here. Bolo, I don't know if you have rights, but if not, let's do this quickly and get you over because Bolo is one of our regulars here on the show. So Bolo, do I see you, Bolo? All right. I don't know if I do, but I'll have to come back. So All right. And with that said, let me introduce Flying Rich. So Flying Rich, and it's spelled with a lowercase f, Flying Rich, Flying Rich. Because some people email me and said, hey, like, make sure the F is capitalized on your, and I'm like, you're one of the few people who can see it, that YouTube hasn't taken the thumbnail away. He's been doing tech podcasts for about 10 years. His YouTube channel is titled Flying Rich, so you can find that. I will have it linked out when I do the blog post for the show. Rich is an advocate for open source software solutions. He's a regular on the Mini PC show on the Podnuts network that focuses on single board computing like the Raspberry Pi. Professionally, he is a cloud engineer. Before being a 3D printing enthusiast, or because he is a 3D printing enthusiast, he combines a love of tech, open source, and cloud computing. He has 1,000 hours of instrument rated pilot, so he's actually a pilot. So, it goes in with the whole Flying Rich. But Rich, welcome to the show.
Thank you. Yeah. Boy, so the pool. I guess let's get into the pool vac issue.
Yeah.
So, what would happen is, if you can see, right there, you can see there's a divot ground into this bearing, and that's because it's actually a bad design. And the reason it's a bad design, let's see if I can show this piece, where the bearings get inserted, the inner race, there's a notch, and the bearing would get lodged in there, lock the bearing up, and then the wheel that's rotating on this would wear a flat spot into it. So it comes as a pair of these as an assembly for $45.
Oh, okay, $45. All right.
So I don't need two of these. I had one bearing that locked up. I found there's like search engines for 3D parts. So Yagi.com or Thingiverse.com. I actually printed two bearings, are the width of one bearing, and dropped them on here, and it works fine. Now, the first print I printed with PLA, which apparently absorbs water. So that failed out after a couple of weeks. I printed it in PETG, which is what water bottles are made of. So It has no issues with water. And I had 4 bearings in the part, and only 2 of them failed. So I'm waiting for the other 2 to fail, but I printed the bearings. The other cool thing is the bearings are printed as one object. So they're pre-made. When you print them, the balls are locked in there. So you grab like a jeweler's screwdriver, just move the balls around and spin it, and that breaks everything free, and then it works. So
Rich, you said $45 to replace the part. What did it cost you? You said like 75. A 75-watt light bulb is basically the equivalent of running your 3D printing system. So would you say to repair that cost you in parts and electricity maybe like $4 or something?
Oh, if it was $4, it'd be a lot.
Okay.
That because I don't know what the electricity rate is and what a 75-watt bulb costs. But filament is like $20 a kilogram, and this is a few grams. I mean, this is probably cents worth of filament. Now, so without the, I don't know if the correct phrase is total cost of ownership, but you got to come to the table with a couple of things. And I am not a skilled 3D designer, so you got to know how to work the tech. You have to have a 3D printer. You have to be able to do a little bit of design work like I did and be able to print it out. So you got to count for your time costing 0 and then 0 overhead for the 3D printer. So and one of the things I'm kind of surprised at with people is they think 3D printers are thousands of dollars. I have 2 Ender 3s here, and they actually had a Black Friday deal of $100 at Micro Center.
Oh my God, no way.
So I think I paid for my first one a little over $200. I think I paid $175 for the second one here. And I've because I'm a geek, so part of the intro there was like the geek part. So I have a Raspberry Pi
Yes.
running the 3D printer. So this is a single board computer. It actually has Ethernet, Wi-Fi, an HDMI port on it, an audio jack. There's camera interfaces. So what
That's
I use is
amazing.
another piece of open source software called Octoprint. And Octoprint you can plug a webcam into, and then it watches the print. So here's the cool thing, is what you would normally have to do, you would have to take a micro SD card and like bring it from your computer all with the pane, right? Copy the file you want to print onto the micro SD card, insert into the 3D printer. Now it's all networked, and the Raspberry Pi controls the printer. There's an interface. In fact, from the slicing software, I can just say print. So I don't do anything.
It's amazing.
The other cool part about it is because it's now networked, I could be 100 miles, 1,000 miles from home, pick up my phone, VPN into my home network. I actually have it set so I can power the printer on remotely. So I'm looking around. I have a power outlet that I hacked that works with my home automation system.
Okay.
And Octoprint has a link into that. So you can click a button on the Octoprint webpage, that's local.
Right.
Turn the printer on. I could send a file to it and have it print, and I could be anywhere on the planet that there's internet available.
That is amazing. So then actually, Rich, like somebody who, let's say that you needed something printed, could somebody access your printer and kind of like print it for you? Like
just about.
If
I gave them, VPN access to my network, sure.
Okay. Wow.
And so this is one of the cool things probably 20 years ago, I heard people like executives in New York City are having people in India do reporting for them, and then they click a button and print it out on their printer.
I remember that. Yeah.
And I was like, wow, that's crazy. And realistically, like, let's say I was working with a team of people designing like this part, the white part.
Right.
And maybe somebody said, hey, you got the test facility, a swimming pool. I'm going to click print and print it out, and then you test it out and see how it is. Or it could be, who knows, maybe you're working, and I kind of dove into the tech, and I'll back out a little bit and I'll give you a higher level view on stuff. It could be maybe it's Northrop Corporation, and I'm an engineer in California, and there's, a test site in Florida. And I'm like, oh, your sintered metal printer, I will print this metal part that please bolt it into this aircraft and tell me how it works. It could be something like that in the future.
That is amazing. Holy smokes. How's accessibility right now with supply chain as far as getting filament and getting or even accessing a 3D printer?
That's a great question. So at the beginning of COVID, I think a lot of people figured, I think during a unique situation, like nobody in 100 years experienced anything like COVID. And then 100 years ago, when they had the Spanish flu, nobody realized what it would be like if we had the Spanish flu in 2020.
Right.
So what the implications were, because realistically, when you had the Spanish flu, a lot of people were probably growing their own food. They probably weren't relying on supply chain. So a lot of people went to Home Depot and started doing home projects. And I guess likewise, a lot of 3D printing people decided they were going to 3D print stuff.
Sure.
So if you had a filament you liked, whether it printed well or you liked the finish of that filament, you were always able to get like PETG or PLA, the different types of filament. You might not be able to get the specific brand you wanted.
Okay.
So it was never, I would say, 100% shortage. But if it was like, no, I like this brand PLA over another brand, it might be that you're getting, brand X instead of the brand you want.
Okay. And so if you're buying, you said you buy this as a kilogram is typically, or like, okay. So what is the cost of that? And
so typically about $20. So a spool of filament, and typically you'll get the filament vacuum packed in a bag with desiccant, because a lot of filaments are hygroscopic and they absorb water.
Okay, I didn't know that, and I wouldn't expect that. That seems interesting.
Yeah, it's
Okay.
plastic. You wouldn't think it had anything to do with water, but
Right. Because
so you could have filament issues.
I remember that was, as you said before, when you printed the pool parts, that was something you were watching. And then also, I think with
Mhm.
heat dispersion, and I was thinking, well, if it's in a pool, right, the heat's going to disperse into the water, so that wouldn't be an issue.
So,
Okay.
all right, that's another cool thing. So, somebody printed a number of parts for the pool vac, and he shared them openly on Thingiverse. And he said, "Well, I would print it in PETG and not PLA." And it's underwater; it's not going to have a heat unless you're doing your hot tub or something like that. But um, it turned out PETG was the right filament because PETG is the stuff water bottles are made out of, and PLA absorbs water. And in a couple of weeks, I had a failure with the bearing. So I reprinted in PETG and printed out a couple of spares, threw them in a Ziploc bag, and
That's amazing.
if I need it, it's available. And the other thing I did, part of like being open source and sharing is I wrote the guy a note, say, hey, you got these parts for this, pool vac. You might want to include these bearings also.
So tell me about this Thingiverse. I have it up on a
Mhm.
screen to the left of me right now, and it's amazing, the number of items that I'm seeing on this. But what is that? And do you have to pay to obtain, I guess, source code from that, or can you upload your own source code and say, "Hey, I made this. Like, I want it to be available for others." So, what is Thingiverse?
All right, so Thingiverse, there's a couple of different places. Thingiverse is a repository, and like there's a flyingRich repository of stuff there. I'll post things that I design, and I'll find things other people designed, and there's also you can tip somebody. So nothing is for sale on Thingiverse. It's
Okay,
all share and share alike. But if you do like something and you think somebody did a great job, you could tip them some money on Thingiverse.
okay. So I'm going to just bring up the Thingiverse
So
screen right now. So this is what I'm seeing right now when I go to Thingiverse.
all
So
right. So I kind of categorize things into useful things and dust collectors.
right, this looks like a
So
dust collector's cactus holder over here, but
yeah, so you'll find a number of different items that are interesting. So okay, one of the interesting things like that QR code, they probably have a generator for that, so you could put in your own QR code information.
okay. So yeah, if
So
you
it's customizable from the site.
okay, that's pretty cool.
So you
Wow.
could put like, say you have a store, you have a coffee shop, and you want to give everybody the Wi-Fi information. You can have them just scan the QR code and get on the Wi-Fi.
Wow. I mean, yeah, that's really cool. Um, so
There's
what is something I'm going to search. What is something I should search for right now, Rich? What do you
somebody
think?
did a cool. This is going to be kind of a corner case thing. Search for business cards. Somebody made a thing that you could take a blank business card, roll it through it, and it embosses your information into it. I don't know if you're going to find it right off, but
Okay. So
yeah,
here's
you're
somebody
seeing
with a big
business card
spreadsheet.
holders.
Right. Okay. So these are some things that have come up. This kind of looks like it. Well, I don't know. Business card glider. Okay. So, okay. I don't
Got
know
a
what
money
this
clip there.
new
I
clip.
don't know that I'd want a 3D printed money clip, but
Right. I don't
the
know.
metal is better. And that's one of the other things. I'll tell you what, search Raspberry Pi and you'll find cases like this. And you'll find there's really a great selection. You'll find some artistic type things.
Okay.
COVID protection helmet. Wow.
Yeah, I'm not trying to wear that. It might be Vanessa, Tinking, JC9. You guys might be wearing that, Andrew, I think, but I don't know. Okay, so yeah. So, well, let's do this. Tell us a little bit more about Raspberry Pi, because when I worked as an administrator for the School for the Blind in Wisconsin, Raspberry Pi was a big thing.
Oh, cool.
And yeah, they ordered several of them and they were teaching students how to use them. And I never really understood what it was. So what is Raspberry Pi? Excuse me.
So,
and how does it interface with 3D printing?
all right, the Raspberry Pi is a single board computer. It's, it's a little bit bigger than a credit card size computer, but when you buy it, it doesn't come with a case. So this is a Raspberry Pi 3, and I know that because I wrote a 3 on it. There's a Raspberry Pi 4 right now. There's different versions of the Raspberry Pi, and they have different specifications as far as memory, CPU, and ports. So it's a computer that pretty much is as powerful as like a 5-year-old desktop computer. And I have Raspberry Pis with 8 gigs of RAM. The original Pi, or like the Pi 3, has 1 gig of RAM, gigabit Ethernet port, and then 4 USB ports and the HDMI port. But I guess we'll get into, here's my Raspberry Pi cluster case I've been working on for a number of years.
What is that?
Basically.
What is
so it's supposed to look like a Mac Pro trash can.
Okay.
And I 3D printed everything. So I got a fan up top, and this is the bottom, and there's a connector for the Ethernet, and there's going to be a single power wire going into it. And then inside, I make the joke I failed at designing a CubeSat because it's a cylinder. There's actually 4 Raspberry Pis and a 5-port Ethernet switch. So basically, they're all going to plug into the one Ethernet switch. One Ethernet wire is going to come out and connect into that connector on the bottom. And it's just going to be a neat way to have, or aesthetically a pleasing way to have, 4 Raspberry Pis and a 5-port switch sitting on your desktop. Now, the way I've been doing it is I'll just stack these. So this is designed to be stackable, and it's not as visually attractive. So you got a stack of 4 or 5 of them and wires hanging out all around. Then you have like cooling issues. So this is to solve a couple of problems. And this is a design I've been working on. Now, the problem is I've been working on this for a number of years, and the switch that I originally designed this for isn't available anymore. The Raspberry Pi, since COVID, have gone up in price dramatically. So that is like $600 and change worth of parts.
Holy smoke! So we have a question from Vanessa. She said, "Are you parallel programming on your cluster?"
So there's a bunch of different things you can do with a cluster, and because I do cloud computing,
yes,
Joe. What I'm more interested in is they have a release of ESXi, that's VMware, that runs on the Raspberry Pi. So I actually have a cluster in the corner here of 4 Raspberry Pis running ESXi, and that's the ability to host virtual machines. So
amazing.
And virtual machines is could do a whole show on that. It's a little bit of abstraction. So what you're doing in a VM, and whether it's a VMware VM or any other VM, is you're abstracting the hardware layer to software. And then the cool thing about that is you could copy it onto a thumb drive, plug it in somewhere else, and it'll run like a computer over there. Or if you have a cluster and say you need to bring one board down, say I wanted to pull one of the Raspberry Pis out, say it failed. Well, you can have it so if it detects failure on this board, it moves the virtual machines onto other boards in the cluster. You could power this one down, swap it out, and then bring it back into the cluster and have all of the virtual machines come back to it. So you could either have high availability or failover capability within that. That's virtual machines, and that's a whole big other topic.
So, Rich, as you described, what exactly was that canister again with Raspberry Pis? What is the function of that?
So realistically, it solves a couple of problems. The aesthetics, it doesn't look awful. It handles the cooling. It handles wire management, so power and network connectivity. And also, you have one power connection, one network connection.
Okay. So, what do you use that for? Like, what is this?
So that's where I plan on putting my cluster in the future. So
Okay.
I got a few tweaks to do on this still to have it 100% functional.
That is amazing. That
And
is holy. And you 3D printed the case for it, or?
oh yeah, yeah.
Okay.
Everything you saw, all the black parts were 3D printed.
Oh my God! Wow.
So yeah, this is all of the fins are 3D printed, so it gives you the, Mac type MacBook, or not MacBook, Mac Pro look, as they call it affectionately, the trash can.
So, how long does it take to print that? And you also said
Oof.
something before, which I think is important, is to run your 3D printer is the equivalent of a 75-watt light bulb per hour. So,
Mhm.
not very expensive.
Right.
But tell me, I guess, how long it would take to print that, and how are you designing that out? Or are you finding that online? Are you finding it from Thingiverse, or where are you getting this information to do that?
So somebody on Thingiverse printed a Mac. They have a design for the Mac trash can, but it was for like a single Raspberry Pi. This is actually smaller. And what I'll do is, so I took their design, so it was just big enough to fit one Raspberry Pi in, which is kind of a cute, desktop thing if you want to do it that way. The reason I have this is because this might take an hour to print or 2 hours to print, whereas the full size one might take 6 or 8 hours to print. So I'll print, like if I'm working on a design, a quarter size version of something just to see if it's what I think it looks like or what I think it should look like. The other part is, if I know I'm going to be printing something that takes a long time, I might print a cross section of it to see like, hey, will that fit this piece correctly?
Okay.
So I don't spend, 10 hours printing something that's going to be flawed. I'll print the most critical part of it, make sure the fit is what I think it should be, try it out, and then I'm like, hey, I know I'm good to go, and let me print the whole thing. And the other part about printing is you don't have to print 100% infill. So
Okay.
sometimes
I didn't know that.
it's not, you might not save any time. Like if you're printing 10% infill, which means it's 90% air, you're going to save a lot of time. But once you get above like 60%, the difference between being 100% and 60% isn't that much. And if you don't care about filament, if you're looking to save filament and you want the strength, you could print 60. If you don't care and you want it 100% filament, you could print 100%.
Okay.
If you don't care about saving money or time at that point. And there's reasons for that.
So, do you think right now, like 3D printers are kind of slow? I mean, would you anticipate that kind of in the next couple of years, an advance in 3D printing will be just faster printers? So, if you want this, instead of like 6 days to print it, it's going to be 6 hours. Is that something you kind of expect or not?
There's different types of printers that will print faster. There's a open source version. It's called the Voron. There's a 2.4 version, and the Voron is supposed to print stupid fast, but it's $1,000 just for the parts, and it's not a kit. It's a bunch of parts. So I know other people are building them right now, and it's a long build process. And that goes down to what's more valuable, my time, or do I really want to do this? And you could get a similar printer for $500, maybe doesn't print quite as fast. So print time is something, usually you trade print time with quality when you're doing FDM. And And that's, what is it, fusion deposition model. Anyhow, that's where I try to describe, people that don't understand 3D printing, I try to describe it as a robot arm with a hot glue gun.
Right.
And people seem to get that. That seems
Okay.
to make sense.
Yes, a robot arm with a hot glue gun. Yes.
Yeah.
Okay.
Except the glue is a spool of filament, and that gets fed into it.
Wow.
So yeah, you can change quality, which is like layer height. So you can do fat layers or thin layers, and thin layers you get higher quality because you're going to have higher resolution. You know, it's kind of like lines of resolution on your TV.
Okay.
You can increase or decrease print speed. So how the print head moves, there's acceleration and deceleration settings. There's settings for how fast it moves when it's not printing versus how fast it moves when it is printing. So there's a lot of ways you can tweak something, and people have gone to extreme measures to tweak their prints so they have reasonable quality, you know, passable quality and strength, but you can print stupid fast.
Right. Okay, I get it. So let me ask you a question, but first, before I get to that, I'm going to share a little insight that we talked about before the show went live. And so when I was a high school senior back in the 1980s, this is a time machine right here. So, woo, time machine. So I, my senior year, I dropped trigonometry and I took plastics, and it was actually one of the best decisions I made. Because I picked up trig later in college, wasn't a big deal. But in plastics class, I made 3 things that I still have with me today. One of them is a fiberglass sled, and my daughters used that on the sledding hill up until they aged out, right? They didn't use it anymore. And that thing held up like a rock, a fiberglass sled. You think about these plastic sleds you buy at, you know, the big box stores, and they last for a season. No, that thing held up. And I also made this here. Believe it or not, this duck. Yes, I made this. Well, this is actually, you know, out of a compression mold, but I made this back in 1989. Believe it or not, here the duck is looking at you. He's talking, "Hello, Rich." He's talking to everybody. "Hello, Vanessa. Hello, Bacon." So I made this duck. Yes, that's my initials on the bottom there. 89, so DP89. And so yes, this has stayed with me here. And then I also made this paperweight, which was basically resin poured into a can, and then you would put something in it. I put a padlock in because I thought, wow, it's, you know, it's kind of like a psychedelic thing. Like, how would you deal with a padlock, a turn padlock, if it's in here? So, and then I poured the rest of it. And I have this to this day. So as I was sharing with Rich, I have 3 things from high school. I probably have 5 things total, and 3 things were from that plastics class. So this is on my desk, and this thing is heavy. So if, you know, you put this down, like it would hurricane winds, like whatever was underneath it would stay in place, you know. But kind of an intro to, I just can't imagine what the high school kids are doing today with all of this stuff. But yeah. So Rich, what got you interested in 3D printing? Like, when was your decision to make your first 3D printing purchase? You're like, I'm going to go out and I'm going to buy this.
I think it was more than 6 years ago, and I have the printer over here. It's a highly modified ANET A8, and I think I got it, was it AliExpress or so, for $150, but it takes 8 hours to build. So the Ender 3 takes 3 hours to build. Now you're not soldering wires or anything. There's a couple of screw terminals, but everything else plugs in. But it's like a giant Tinker toy as far as all of the screws and everything. It was it's laser cut out of polycarbonate, and there's a lot of parts, there's a lot of screws, a lot of nuts, and just a stink load of work. But now here's the cool thing about it: because I built every single part of that printer, I know how to fix it. I know every last thing about it. Where I had an issue with the Ender 3, because it comes mostly assembled, the thermistor that measures how hot the hot end is, the glue gun part.
Yes.
The thermistor went bad. Like, so diagnosing the thermistor issue took me a little bit. I'm like, what the hell happened? And then trying to figure it out. I'm like, well, how does the thermistor go in there? Because I didn't assemble it, was another part. So not that it's that hard, but I didn't have that familiarity because I didn't build every last bit of it.
Okay.
So that took me a little bit longer, like to diagnose the issue and solve it.
Yeah. That's amazing.
But I would highly recommend the Ender 3 to anybody. You know, I wouldn't say it's a beginner printer. It is, because it's a great entry level, but it's not a beginner printer because you're going to want to get another better printer in a month. No, it's really, it's something you can have and be very useful. You can start off with it, and I have 2 Ender 3s right now. So I got into 3D printing over 6 years ago. Okay. And just because it was a tech thing, and mainly because of Raspberry Pis and being able to print project cases, to print a custom case that I would want and I'd want to modify. So a lot of things, I almost never print something straight off Thingiverse. I'll add something to it. I'll modify something on it.
Okay. Wow. So here,
Creality has a bunch of great printers, and the Ender 3, you know, there's a couple of different versions of the Ender 3. There's the Ender 3, Ender 3 Pro. I'm not sure exactly what the difference between the 3 and the Pro is. There's a couple of modifications I do. One is a magnetic bed. So when you print something, you just pull the magnetic sheet off and then flex it a little bit and your parts come free. So that makes it a lot easier. And you're not messing with the bed leveling, so that you don't have to level the bed each time. So a higher end printer comes with like auto bed level, which is kind of a feature, but bed leveling, people seem to make it into a big deal. I don't think it's that big of a deal. But if the less bed leveling you have to do, the better. And if your printer automatically bed levels, it's kind of nice, but I wouldn't say it's a must-have.
So we have a question from B3 Outdoors, and he's saying, you know, the big government types will try to ban 3D printers. Is that something you've been thinking about as, and I guess let's get into this, Rich, is what is open source? Like, how do you get files for 3D printing? Or if you modify, for example, a file and you say, here's this, you know, part for my pool printer. Now you want to make it available to other people. Are you seeing some changes happening right now of like, you know, open source? Is open source being more restricted, or is actually maybe the opposite happening? I know during, I wrote about it in the Velocity of Information when PPE was at, you know, short supply. There was a removal of copyright and trademark, so people could print these things from their home 3D printers and provide them. Drew Bay, for example, is one of the people who did that, who's a friend of the show, provided them to hospitals and things like that. Where do you see right now with like 3D printing, and where have you started to observe either some government encroachment on this, or anticipate, or because I think it's a great question from B3 Outdoors.
So I guess there's a couple of layers to this question. Could the company that, you know, the pool vac I have, find the guy on Thingiverse and say, hey, these parts are, you know, copyrighted? And then that goes into copyright. What is copyright? How different does it have to be copyrighted? And I'm replacing their single bearing with 2 bearings. Could they come after me for, like, if I post this on my Thingiverse, could they come after me and say, hey, by the way, you're violating my copyright? I'm like, well, not exactly. It does fit on your part, but I'm replacing it with 2 bearings where you have 1. Your bearing is, you know, stainless steel balls and whatever plastic or rubber this is. I'm doing it in PETG and it's all plastic. So there are issues to that. You know, anybody can sue you for any reason or make a claim against you for any reason. I think copyright with objects it has to be like 20% different, if I recall correctly. Don't take my words, look it up.
Sure, sure.
And even so, I think I found this on Thingiverse, and I wanted ears on it that I could screw it onto something. I added the ears, and so you can quote unquote remix. So if you look on Thingiverse, somebody might have this Raspberry Pi case, and if somebody like me was kind, they would upload their remixed version with like ears that you can screw it onto something like a 3D printer and share it. So you could, if you look at something on Thingiverse, just like GitHub for software, somebody might fork the code and make a branch of the code, and then edit the code with their special sauce, whatever remix they want to do, and then post it and reshare it to people.
Wow. That is so. Is that growing right now? Is that something that's taking off? If it's not Thingiverse, where else could people go to find, I guess, templates for 3D printing?
Yeah,
or
like
ideas,
Yagi.com. There's a number of 3D search engines. You could Google 3D object search engine or STL search engine, and STL finders I saw somebody mention. So there's a number of objects out there. I kind of a thought exercise, like to troll the front page of Thingiverse or Yagi, or pick your favorite one, because maybe I'll get an idea of what I can do with a 3D printer that hasn't been done in the past.
Got it. Wow. So what do you so think about at home? What are some things right now that people are able to do with 3D printers, and where you anticipate, Rich, in the next maybe 2, 3, 4 years, people who have home 3D printers will be able to print things that we kind of don't think about? Because again, I mean, when I talk about 3D printers, just in general, people are like, "Oh yeah, you can print like a flute or a business card holder or something like that." It's like, yes, you can do that, but now there are more things, as you indicated. The stand, the special mounting brackets for your TV, replacement parts for a pull printer. But where do you see this? And is it also, do you have to have CAD skills? You can look at things and replicate that, or can you maybe outsource that to somebody else of saying, "Hey, I have this," and then because I guess as I lead into this, when I wrote in my book, The Velocity of Information, I said, back in the 1980s, it was a warehousing environment for manufacturing. And then it moved to just-in-time manufacturing. And now we're kind of in this just-in-time, but we're also transitioning quickly to 3D, where I know I read a white paper, and it was about, I think, AutoZone or Napa. And they said, in a couple of years, they expect that somebody comes in and they say, "I need a fuel pump for my, 2008 Impala." And they're like, okay, they're not going to go back to the shelf to grab one. They're going to take your VIN number, program it in, and then give you some options, and then hit print. And in a number of minutes or whatever, it'll be done, and they'll take it out of the printer and hand it to you and say, "Here it is." So, so I think, what are some things that you're able to do now, or you've seen other people able to do? Because I think there's this myth that 3D printing is still a novelty. It's still kind of, oh, it's Christmas gift. I got a 3D printer. Like, this is great. And, now I can do like an articulated robot, or again, a flute or something like that. But it's like, no, we're beyond that. And also I think, your take on this, of how this is going to interface with maybe, our regular shopping, or Walmart, or if you're going to just have a subscription, are you going to go online and say, "I need whatever to be replaced, so I'm going to download the code for it, and my 3D printer will print it right here in my house"?
So one of my friends was thinking, so there's like 9 answers to, and maybe more than what you just said. So that could be a whole nother show. So let's see. I think there's a couple of different models. There's like, hey, what works for me in my house, and what do I want to do? Now, if I want to print Precious Moments figurines, type stuff like that, what I call dust collectors, and I'm sorry if I offend people, that's my person, my view. You might want like a resin printer, and resin printers have come down in price because you're going to get that fine detail. You're going to be able to print like that size volume of thing. And if that's what you want to do, that's very cool. And again, not my niche, but I see other uses for a resin printer. So for home printing, you're probably going to be doing resin, or you're probably going to be doing FDM, the filament type stuff that I do. And just because a filament printer is sub $200, and I think there's a lot of useful things you can do with it. For somebody like a Kinko's model, like whether it's AutoZone or Home Depot or Kinko's type thing, where
Yes.
hey, it used to be you didn't have a nice laser printer at home. You might want to print your resume back when you had a paper resume and threw it in your briefcase and went out on an interview. You went to a Kinko's, and maybe Kinko's has people, and I'm saying Kinko's like Kleenex in the generic version. Maybe Kinko's has a higher end printer or a faster printer, or maybe they do, laser sintering of metal. And that might be like the AutoZone model. Maybe I need the socket that's 34 millimeter for the hub assembly on my truck, and they just don't have a 34 millimeter socket in stock, but they'll print me one. They're like, hey, you can pick it up in an hour, that kind of thing. It could be that, Kinko's has skilled people that'll help you with things, and they'll have a specialty printer to do the thing you want. Am I getting a lot of noise in? Do I need to close my door?
Oh, no, this sounds great.
Okay.
Yeah, everything's good.
I think the other thing about it is, if you think of everything, or if you only have a hammer, you think of everything as a nail. And I think the idea is that the end product in 3D printing maybe shouldn't be all 3D printed. And just like today, I printed, or last night, overnight, I designed a mount for the TV, and the mount was basically extruded metal conduit. And I printed drill guides so I could drill the holes through it. And so one of these drill guides doubled as just to keep this upright. In other words, lock it into position. So I put one this way with a screw through it, and then I drilled this hole. I flipped it over and then drilled the hole on the other side, where this locked it so it wasn't rotating around. Like if you try to drill around tubing, it's kind of a pain because it'll roll, and you don't want that to happen. So that kept my alignment for the holes I had to drill. And then the other part was the screw went through, and so I needed it spaced off the back of the TV for the mount that I put in the wall unit. And then this is a short screw, so the screw went through. And also they had screws that were too long for what I wanted, so I actually printed a longer spacer, so it worked. So I think plastics are good for many things, and you could actually do, there's a lost wax process where you can make a casting of something like a brass or bronze casting, and you would carve the wax, and then you'd put plaster around it, you'd melt the wax out. Well, people are doing that with PLA plastic. So they're printing something in PLA and then encasing it in plaster and then melting it out and then pouring, bronze in and making a casting from that.
So what might be an example of that? Yeah, that sounds amazing.
People print sculptures, people print, complex parts that they're going to machine later, that you need just the general shape cast.
Right.
It's really limited to whatever your imagination is. So if you think back, hey, what did people used to do a lost wax process on? And you can actually print a filament that is wax and water soluble. So there's a whole bunch of printing techniques that we didn't even hit on. So you asked a couple of questions about what's going to be the future. I think it's kind of only limited to your imagination. When all we had was wood and metal, you would print things, or you would build things out of wood and metal.
Right.
And now we have the option of plastic. And so here's a VESA mount. I was working on redoing my desk monitor setup.
Yes,
and
I recognize that. Yep.
So I was like, oh, I can print VESA mounts, and I could use metal conduit as the stand.
Right.
And, people have printed plastic, but when, again, going to the hammer and the nail routine, if you think of everything, or if your only tool is a hammer, you think of everything as a nail, I think it's combining different items, different techniques and processes.
So Rich, you showed that mount. So if you were to, first of all, how did you get that mount? Did you go online to like Thingiverse?
Yeah,
Okay.
Thingiverse or Yagi, and looked up Vesa mount, and I found this mount.
And for you to print that, how much would that probably like cost you in electricity and filament?
So there's one more cool thing I want to make sure I get in. So before we close, I might have done this 100% infill. This may have taken probably under 3 hours. It's been years. I got a bunch of stuff in a container for storage that I just pulled things out so I could hold up and show. So the ability to be able to just download and print something blindly and having no intellectual effort in it, meaning you didn't design it, is great, because you know what? Who cares how long it prints if I wake up in the morning and it's there, and it costs $1 or $2, and it, as far as material and electric, it's probably under $2. Who cares?
That is amazing.
If it takes a couple hours, let's say I laid out 2 of them on my printer and it took 8 hours to print. I wake up in the morning and there it is. That's the greatest thing ever. That's better than overnight shipping from Amazon.
It is.
So a cool thing that I wanted to tell you about is what somebody did. And when you think about, everybody understands a fax machine, but they don't. What they know is you stick paper in it in New York and it comes out in California. Right. Nobody understands the real technology, or very few people understand the real technology, but that makes sense to people. But when you told somebody, I'm going to scan it and email it to you, they're like, I remember I wanted to email somebody a resume that I scanned. Like, no, we don't accept attachments on our emails. That's a violation of our IT policy. I'm like, I don't want to do business with you in the future.
Yeah, that's crazy.
But what somebody, where I think they worked at Cornell or so. So I'm going back 20 plus years probably.
Okay.
They had a 3D scanner and a printer, a resin printer. So they actually 3D printed somebody. They scanned a person and 3D printed them. So now they have like a Barbie doll of the person.
Right.
But realistically, you could 3D scan this in New York and print it in California, and you have a 3D fax machine.
Oh my God.
When you think about it, I mean, effectively, we're kind of, it's less interesting when you say, oh, you can download this on Thingiverse and print it. But when you say, oh, I scanned this in New York and you printed it in California, it's a 3D fax machine.
Yes, that's the part of it that I think people don't understand, is how the network allows for this to happen. Or you could say, like, I'm encountering this specific issue and I need this piece, and somebody can look at it and submit that to you, or or maybe they have the equipment to print it, and then they print it and then they send it to you or something like that. But yeah, whatever. Wow.
So I think there's niche type things. You might be in Antarctica at a research station. You might be in the space station orbiting the Earth. You might be on an oil drilling rig in somewhere. And maybe you need a plastic part, because I had this happen the other day. My daughter's shower, the valve went bad, and there's actually a valve removal tool.
Yes.
I ordered, I went to Home Depot online. I clicked valve removal tool, silicone lube, and the valve cartridge. And I went and I picked it up. But realistically, they had a little plastic piece in there that would have enabled me to remove the tool. Theoretically, I could have 3D printed that tool if it wasn't included. So you could be in a remote location where you don't have the ability to go to an AutoZone or a Home Depot, you could 3D print the plastic part that you need to remove something. You could maybe, if you have a laser sintering, like 3D print the metal tool that you need to use, or the metal part that you need to fix something with. So I forget what company, they're 3D printing rockets and the rocket nozzles and a number
Wow.
of parts. I think it's Electron is the company, and they're using 3D printing to 3D print the rocket engine, the rocket nozzle. And there's different materials for that. There's different reasons why you would or would not do that. One part is the ability to rapidly prototype something. So maybe I have an idea on some new thing I want to design, and it's going to be built in metal. But maybe I want to do a 10% infill just so I can see how it physically functions. So I could put it on a desk in a room with a bunch of people, or distributed. I could have a bunch of people in 6 different states, have it printed on their printer, and they pick it up and hold it and figure out how will this work in this new product. So even the TV mount that I did, I would have placed the holes in different locations where I was screwing it to the wall if I had it laying in front of me. But in 3D space, it looked like that was good enough. And actually it is, because the TV
So it
is
worked.
on. It worked. But I would have moved the holes a little lower. I would have added a little more meat here. So the ability to do something in a lesser quality, that like not production quality, and hold it in your hand, look at it in physical space as opposed to like the 3D design space, you might say, hey, I'm going to do that a little different. So instead of printing an object that takes an hour to print the final product, maybe I'll print either, like I said earlier, a 25% scale size so I can get an idea of what it looks like, or something that doesn't have 100% infill that I can print rapidly and figure out, I'm going to do that a little different.
So, Rich, we have a question from Heather. And she said she's curious, how do these 3D printed parts, I guess, at home hold up to, I guess, what would be a traditional part? She said her dad, like Snap-on tools every day, 3D print. So, is it comparable? And one thing I guess I've been learning more is 3D printing is moving into metals. And being able
Yes,
to
so
make
the
things
laser
right.
sintering. So basically what happens is they'll push, like they'll rake, if you would, a layer like a thousandth or a few thousandths thick of metal dust. And then a laser will come by and melt it. And then it'll repeat the process. And you could build complex parts that way, or a tool. You could build a crescent wrench. Yeah, I
Okay.
could 3D print a plastic crescent wrench. How good is it? Till it breaks, Might be good that one use, might not be good for 2 uses.
Right.
But something that you 3D print in metal could be, good for months, years, depending on how bad you are on your tools. Look, Snap-on tools break also, and they have a guarantee.
Right. It is, as Vanessa's saying, like there is a 3D printed titanium bicycle. And so I think this is just a matter of time, not a long amount of time, before, whether it be metals or what is it, like graphene or these other
Sure.
composites they're very durable and so
Now, you can use 3D printing. So, boy, I don't want to keep you too much. How long do you want to run? Do you want to run just an hour? Or?
we can run. No, this isn't confined to
Okay.
an hour. So
All right.
it's
So I'm a 1,000-hour instrument rated pilot. I have 600 hours in Canards and 400 hours in Cessnas. Now, one of the cool things is EAA is the Experimental Aircraft Association, and EAA had like, oh, you can, like, if you're going to build out of aluminum ribs for a wing on an airplane, you can stack these parts and this rubber together and put it in a press, and you could come out with what they would call a hydroformed part. But there's actually a better way to do that. and you could 3D print, the mold. Like I've seen people 3D print dimple dies. So if you want to strengthen something, you could actually 3D print, the male and the female parts to sandwich the aluminum in between, and put it in a press and crimp it. So that's pretty exciting. The idea that the final object is going to be the plastic you printed, I think, is limiting when you think like, hey, I could make a die that I'm going to press a rib for an airplane wing in. And really where I was going with this is Burt Rutan is a designer. Actually, he built Spaceship One that Richard
Wow.
Branson is doing now. And he joked that he built a spaceship out of parts he ordered from Aircraft Spruce.
Holy
So,
smokes.
and the reason Burt Rutan did what he did with the composite airplanes that he designed, so the Very Easy, the Long Easy, there, and I could talk many hours about Burt Rutan alone in his designs, but very innovative designs. But the reason Burt Rutan is who he was and did like the Very Easy and the Long Easy is because he worked for another designer, Richard Beatty, that designed the BD5. So there was a piston engine BD5 and then the BD5J, which you might have seen in the James Bond movies, a microjet, as they call it. Beatty went out of business several times in his career and ended up not delivering the piston engine. And what Burt wanted to do to solve the problems that Richard Beatty had, and really the problems of the consumer of the kits for the airplanes, was Burt Rutan only wanted to sell you plans that you could build an airplane from. You didn't have to buy molds from him. You didn't have to buy anything.
Gotcha.
The way his planes were designed were like a surfboard. So you carved foam and then laid fiberglass over it.
Nice. Okay.
And it's a little more complex, but generally that's how you built a Burt Rutan designed airplane. In this way, if Burt Rutan ever went out of business, you had the plans. You could order fiberglass from Aircraft Spruce or Wix Aircraft. The resin, the fiberglass cloth, whatever components you needed to build that airplane, you could call them up and say, hey, send me this, and build it yourself. In the canard community, there were a wheel pants mold going around. And it's kind of on the honor system, and you want to build wheel pants for your airplane. Here's a mold, and you can use the mold for a month or two and then send it to the next person on the list. Well, it actually kind of stalled out, and somebody's like, well, I've had the molds for so long, I think they're mine. It's like, what? You didn't pay for the mold. Somebody sent it to you. What I wanted to do was do a 3D printed mold in its multiple sections. So you could 3D print your own mold. And if you wanted to send it out to the next guy, you could do that, or you could just have it. And I've got a mold for the wheel pant myself, and I click print on the printer, and maybe it takes a week or two to print it. You're not going to print. There's kind of ways to cheat. So you might do a 10% infill, but with like 6 or 8 layer lines on the outer shell, and that'll get you a really good mold that you could assemble like a bunch of blocks that go together, and maybe you put threaded rod and like lock it in place. And that's the mold for your wheel pants. This way, just like Burt in his concept of, hey, you're building an airplane like a surfboard, foam in the center and fiberglass on the outside, you could say, hey, here's the wheel pant mold. I'm giving it to you on Thingiverse, click print, and you got your own mold. And then you don't have to worry about how long am I going to be on this list before I get my mold.
Man, that is amazing. That is amazing, Rich.
Or some of the more complex shapes, like when you have, it's easy to moldless construct something that has a curve in one dimension. When you have something that has multiple curves, that's complex, it's tougher to do in a moldless fashion. So some components that have multiple bends in different dimensions would be easy to 3D print, and throw some mold release on and lay some fiberglass over, and make as a fiberglass product.
Okay. Wow. I mean, this is amazing to listen to this. Do you see this, Rich, happening at home, or do you think, like local stores, right, are going to have 3D printers? So if you need a part for something, or even, I guess, like a Walmart or a Home Depot or things like this, or
Well,
subscription, you're just going to order, and it's going to be printed and sent to your house. I mean, where do you think
so
these things are going?
yeah, there are services out there. So I don't. I've always been toying with the idea of running a print farm at home. So I could join some community, and I don't even know the names, but I could look them up. And just like Uber, there's the ability to 3D print. And so, good question here. So, there are groups like Uber for 3D printing where you could say, "Hey, I'll print that." They get a little bit of a cut. You print a part, and you make some money on it.
Okay.
There's ways of doing that. Some people are saving their 3D prints and they run them through like a grinder and like a garbage disposal. Basically, they have a bunch of filament. You melt it down. You could do that if you're an eco warrior, and more power to you. That sounds too high effort. Then you have to have the machinery to heat it and extrude it. And filament has to be a very precise, consistent width. So you want a consistent density and a consistent, string width. You don't want the diameter to increase or decrease. The quality control on that is just something I'd rather not deal with personally. I'm happy to ethically recycle these things and, throw them in the right waste container. Or save them for somebody else. Like if there was somebody in Palm Beach County that said, "We'll take all your 3D printed PLA parts and remelt them into filament," I would absolutely be happy to, bring a trash bag to somebody. But yeah, there are ways to do that.
Okay. That's amazing because I was looking at a video produced by the World Economic Foundation or something, like in the last 2 days, and this video was saying like, "Hey, people, don't like wash your clothes because it contributes to global warming and stuff like that." It's pretty crazy. I'm going to talk about it on Face Validity Friday, but I look at 3D printing as very environmentally friendly because you don't have excess product that you're printing and having to trim off the sides necessarily. You're not having excess product that's going onto shelves.
Well,
Like warehousing in the 80s, had to print, or you had to make, thousands of items and then hope they would sell. So I think
sure.
3D printing is, and yet, like I guess we don't hear it described as environmentally friendly and kind of environmentally responsible. And I think it should be.
So
Like there should be a center
let's
topic.
let's talk about electric cars and total cost of ownership.
Sure.
People, I don't have, I don't think electric cars are ethical or environmentally friendly, and that might blow people's minds because there's a lot of problems with an electric car. And let's take Tesla, and I kind of, there's a number of problems with something like a Tesla because you have rare earth minerals that are strip mined in China by people that basically are slave labor. So, like we talk about engagement rings and blood diamonds, and like how the De Beers diamond is ethically mined by people that are well paid, and they're not blood diamonds. You believe what you want. The next problem is
Right.
an electric car. As far as I'm concerned, it comes down to cost. Is it going to cost me less to go from point A to point B? And that's all I care about. Now, I'm half lying on that. I do care about the environment. The next problem is if I pay $80,000 for a Tesla and get free electricity at the supercharger, that versus my 2007 Envoy with 178,000 miles on it to get 16 miles to a gallon that I paid $26,000 for, basically, I would never recoup that driving cost because that was an early argument I had with my daughter on the car.
Right.
You're never going to see that fuel economy. I did not spend, I don't know, $60,000 worth of fuel on my Envoy, even though it has 180,000 miles on it.
Right.
Then the next part with something like a Tesla is, do they ethically recycle the batteries? And in a crash, I forget which guy it was from Top Gear, but he crashed a Rimac, which is an electric hypercar. The batteries caught fire for 4 days in a row in the junkyard that it was brought to. So
Whoa.
there's a number of issues with, and let's just say batteries are made from, they just appear magically.
Right.
You're still driving what I call, it's not a zero emission vehicle, it's a displaced emission vehicle, because the smoke is coming out of a coal factory 50 miles away from where you plug it in. So it's not zero emissions. So anyhow, that long, mental exercise. Plastics are great in a couple of ways, because one, like you talked about, there's zero warehousing. I'm not commissioning somebody to design a mold to make a product. And typically, like if I wanted to, let's say, have this injection molded, that's a $200,000 item.
Holy smokes.
For the first one. Yes.
Okay, right.
To have the mold, designed and milled and machined, and all of everything that goes into making something like this, that's $200,000 just to get off the ground to make the first part.
Okay.
And then it's getting time in the factory that molds the plastic, etc. So ethically, I would say there are definite pluses to it. There's environmental reasons why you would do it, environmental reasons for the type of plastics. Some plastics are basically UV soluble and biodegradable.
Okay.
I think, it's you have to be a bit of a tinkerer in, we had a chat the other day, and a number of people that do design work in 3D printing, and they say, if you're just the guy that downloads something and clicks print, you're missing more than 50% of the value that you can do design work and modify things, come up with new things or new ways to solve problems. My goal when I 3D print is not to have to go to the hardware store and buy a screw or a spring or a latch.
Right.
It's to be able to design it in the whole complete thing. So, like, here's a lid and the lid snaps on. So I don't need any fasteners for it.
Okay.
You can even, like, the bearing, so that all of the parts are here, that I didn't have print an outer race and an inner race and then go buy metal ball bearings and insert them.
Right.
That it's a whole product is a Raspberry Pi case. There's a Pi Zero, and you can print a case with a hinge.
It's
so
amazing.
You print it flat. The hinge pin is already integral, and you fold it, and that's your case. And it has a snap, and it latches and locks. So you don't need a hinge pin, you don't need a latch. Those are the things that I always look to. Or actually, here's a clamp, and the guy that designed the clamp didn't put a hex recess for the nut. I mean the bolt. So the bolt head, if you have a hex recess in there, all of a sudden you don't need another tool. It just slides in. And then on the other end, people, I grab other people's parts, and instead of buying a wing nut, you could just put a regular nut here and make a 3D printed wing portion of it where the nut drops in a hex recess, and then all of a sudden you have a wing nut that's, easier to manipulate than having, a wrench that you need to put on it. So if you do a combination of things, a little bit of smarter design work, like somebody else designed this clamp, and I found this clamp useful for a number of things, and I made some enhancements to it. So most things, like here's a phone clamp, but because I have a newer, bigger phone, I actually extended this person's design. It's designed to work with a nut and a bolt and be captive and work on a GoPro mount. So this is a, commercial GoPro mount but what I printed was this, and I'm like, all right, how could I change this and maybe use like a heavy rubber band or maybe a large O-ring as like the rubber that holds this and my phone in. So I'll just pull it open and my phone will go in. So I think there's a lot of great things you can do with 3D printing, and it's really limited to like what your mindset is. I've
love
seen.
it. And Rich, I want to get to this question B3 Outdoors had. No, so this is amazing. So he's saying, 3D printing is creating less dependency on government and corporations, right? Because, right, if we have the ability to do this in our homes or just down the road, or even through some network where we can kind of co-op this stuff, there'll be,
Sure.
he said, that'll be a political issue in the future. Give me your thought on how do you see 3D printing, I guess, interfacing with political friction in the future, right? Because politicians will probably be like, we want to tax us, or big companies will be like, well, we don't want people to 3D print this
Right.
because we typically have a monopoly on these things. So where
And
do
that
you
kind of relates
where do you
back
see
to an
this?
earlier question. I kind of didn't hit on it because I got sidetracked. But so one, the ability, like, hey, what can I do to grow food from 3D printing? And so there's aquaponics and hydroponics, and people have all sorts of fittings or vertical grow towers that you could 3D print. And they're like sections that stack. So you could have a vertical grow tower, and even the cups that hold the root basket, you can 3D print. So as far as food, and my wife won't allow me to do certain things. I have a screened in area on my porch. I live in South Florida, and I would love for the South end to be vertical grow towers with, aquaponics or hydroponics, and grow, tomatoes that way, let's say. But my wife's like, yeah, I don't want that on my pool deck. But so, yeah, you can do food type things. Even you probably could 3D print something. There's clear plastics. You probably could 3D print something that would help you with desalination, maybe not on a large scale, but on a small scale. I guess it's really unlimited, the number of things you can 3D print.
That's amazing.
And I know there was a suit, this might be 10 years ago, that somebody sued over an object. It might have been something in a movie and somebody printed a character. I forgot actually what it was. So filament, I guess, is they don't do well in the cold. I guess it depends on what filament you're printing in. So PLA, PETG, maybe not. You might go with where there's some higher temperature filaments that do well in the cold. So you could print something. It might be on the edge of what a Ender 3 can print, but you can print is it polyurethane? So polyurethane.
Okay, polyurethane.
And depending on how cold you're talking about, are we talking -40? Or are we talking, just below freezing?
So Man Against the Masses is saying, hey, maybe 3D printing will be they'll control it, like maybe. So this is something where, Rich, I haven't seen this really a lot with legislative initiatives, right? Like I've seen Louis Rossman with Right to Repair, but I haven't seen.
Oh, love that guy.
Yeah, so do I. I absolutely do. And I haven't seen much as far as like the right to 3D print. We saw that in California, for example, John Deere. So if you bought a new tractor, right, and you tried to replace it on your own, if you did that, you turn the key and start up, it would ping and it'd say, oh, like this was modified, but it wasn't by a John Deere distributor,
Sure.
so it won't operate.
So, like an oil change.
So no kidding. So I think we're at this point and people aren't aware of it, but to me, 3D printing is awesome. This is the future. This is the transition. I wrote about it in my book, from warehousing to just-in-time manufacturing to 3D printing. And this is where the 3D printing community needs to be very vocal with their legislators and say, hey, like, Don't interfere with this, right? Don't make it so 3D printers have to ping up to the internet. And one thing I pointed out with the CASE Act, for example, which went into law a year ago, January of 2021, is there was some hint within this legislation that, for example, it didn't explicitly say this. So I don't want anyone to say, no, Doc, it didn't say it. No, I know it didn't, but there was some implicit factor of that indicated if you were to print something, you would need to check first that it was not copyrighted or trademarked. And for me as an author, I know that every time I do that, that's $200-300 that I have to pay to run a search on that. So if you're looking and you're going to print these bearings, these parts for your pool vac, and they're saying, well, Rich, that's fine, just make sure you do your search ahead of time, which is $200, and you're like, well, it's $45 to replace them if I order them to the company. So this is a point where I think the community needs to be aware and then also stand strong, and I think the community will prevail.
Okay, so when did you graduate high school? What year was it?
Oh my God, it was a time machine, Rich. It was a time machine. It was 1990.
Okay.
Yeah, the time of the first.
All right, so it'll be more pertinent why I asked this. Yes. I graduated in '83, and did you go to rock concerts or any kind of concert?
I did. I absolutely did.
So we're talking about going to concerts as a kid in the pre-cell phone age.
Yes. Yeah.
So the first concerts you went, they used to check that you didn't have some recording device on you when you went into a concert. So you wouldn't bootleg Pink Floyd or Led Zeppelin or something.
Yes.
Now everybody goes to a concert with a crazy good recording device, not only audio, but video.
That's amazing. I didn't think of it that way. Yeah.
So this, I think, is like a great example of the ultimate rebellion, that everybody has a cell phone going into a concert. You're not going to take everybody's cell phone or tell them they can't have a cell phone, or nobody's going to go to the concert. And likewise with 3D printing, I need to look something up beforehand. My printer needs to phone home. Well, guess what? My printers have zero phone home capability, or I've pulled it out of them because I built my damn printer from the ground up. And same thing with drones. Like I could build a drone with an Ardu pilot, and I could 3D print the arms and 3D print the propellers and stuff like that, or 3D print the mold for the propellers because 3D printed propellers suck. And I could program the Ardu pilot myself. And like John Crump talks about, there's a house in his neighborhood that there's an exclusionary zone you can't fly a drone into its airspace. So it's geo-fenced off. I can build my own drone. I can order the parts on the internet, have them delivered, and build my own drone. But somebody mentioned earlier that how would you control me from 3D printing? Well, the way you control me is this here.
The filament. Okay.
If I can't get the filament, I can't print. And if I have to justify, yes, I printed 3 Pi 0 case, I'm like, no, this is an Orange Pi 0 case. So yes, I bought 10 kilograms of prints. I had 2 failed prints totaling this many grams of filament, and I printed and sold a bunch of these. But if you tell me, oh, a vase amount is copyrighted and I can't print, well, I didn't print any vase amounts. I printed the equivalent weight of these cases. I don't know. It could be a tough one to control. Like, it's kind of like saying, Mr. Hughes, I saw you ordered so many sheets of 3/4 inch plywood, so many boards of 2x4s. Did you build a trebuchet in your backyard?
Okay.
Because trebuchets are illegal.
Oh my goodness. Okay.
So it's kind of I like the cell phone at rock concerts. I think the American people kind of have a whole FU attitude. No, I'm going to do what I want. This is part of freedom. And I think there's going to be enough of us out there that say And I think specifically everything I've talked about in 3D printing, like Octoprint is open source. A lot of the stuff on the Raspberry Pi is, almost all of it is open source. The operating the system the Raspberry Pi runs on is open source. Cura is open source. I'm using Tinkercad, which is open source. That's the tech community I grew up in, was all like free and share and, you know, supporting each other. You know, kind of the Linux type open source software model. And I think a lot of us that 3D print have that mindset. So God bless the government if they decide to, you know, limit us. We're not going to put up with it. You know, kind of like Twisted Sister, we're not going to take it.
Right. We're not going to take it anymore.
Bunch of Long Island guys.
Da, 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 da. So I think you're right on. I think it's become too big, and so the corporate interest, right? I mean, your big box companies and other. Well, I mean, I guess there's a ripple effect of how they're going to navigate with this, or are they already thinking, are we going to make a subscription service, right? Like an AutoZone or an app or things like that? Because, you know, so one of the things, Rich, right now is people talk about the supply chain crunch. And my counter to that is I said, yeah, that exists, but it also exists for a reason that you're not thinking about. And the reason is because we are morphing into 3D printing right now as a society, home 3D printing and also business 3D printing. And that's the part that no one is talking about. And so I wrote about it, right, and things like that. But so, for example, my friend Robert Travis, who was an Alaskan crab boat deckhand, right? You know, the most dangerous job on earth. But he said, you know, one of the things right now with the crab boat deckhand is, would you invest money if you're a boat owner to make that safer, right, for the deckhands, or are you kind of looking at this is just going to become automated at some point, right? Like bringing in the crab, you know, the crab cages and so forth like that. It's closer to being automated than it is to like training our people better and doing more safety mechanisms. So, you know, that's the part too, is we're getting at this thing of, I think people are almost, I don't know if there's despair, languishing and things like that, or like this whole system is broken. I'm like, no, that's not really happening. We're transitioning to a much better system that will be incredible. I mean, like, it's amazing. Like, we have a microwave upstairs right now, which is possessed by the devil. Every time we open the microwave, it starts, which you think default, like the engineers would have programmed that out of it, right, Rich? Like, you wouldn't and my brother-in-law opens the door and he's trying to figure it. I'm like, dude, you want to probably close the door here before we figure, or let me unplug it. But remember, you know, like what a big thing it was to have a microwave, you know, 30 years ago on your kitchen counter. And I think it's kind of this whole thing, right, of like, we are becoming this is just happening, and it's a great thing. I mean, it is a great thing. And this is where I want to also touch upon, you know, we talk about community safety, disaster safety. You talked about a few things, how 3D printing could be an incredible asset during a disaster. One of those things, for example, was an antenna. Another was, for example, during the pandemic, PPE. I know Drew Bay has, you know, done that personally, has printed PPE and has distributed it out to hospitals. But where do you see 3D printing, maybe, let's say, as a safety mechanism, or maintaining systems that are maybe outdated, where you can't make parts for them anymore, but if you could make parts, they would maintain themselves and be safe, such as maybe ventilation or things like this. So
what happened early on, so a couple of things. People, you kind of showed somebody with printed protective mask. You could print all sorts of masks. People were printing like the brackets for like these thin Lexan masks. So they would go over your ears, and you would just snap the plastic grill in. And so people came up with very rapid ways of changing your settings on how you could print, you know, n number of these brackets to put the mask in quickly. People were printing like a mask to breathe through, and that you could put like filaments in. There was somebody else that came up with a system where you could take one ventilator and branch it into 4 different ventilators, and they 3D printed the parts to do it. We talked earlier, like geodesic domes, say you have a disaster and you need shelter, people could 3D print the parts to build a geodesic dome. Or let's go into 3D printing concrete, like we're covering from a disaster of a tornado or a hurricane. You could 3D print shelters, maybe not a great home or something like that, maybe not so quick, but you could 3D print, future shelters for people. 3D printing is still kind of slow.
Right.
So it's not, Johnny on the spot disaster ready.
Just tell us about like a geodome type approach of maybe let's say right now it's because we've had two tremendous disasters happen. One is the tornadoes, that destroyed substantial parts of Kentucky and the whole line, and then out in Superior, Colorado, the firestorm which destroyed in that region like 1,000 homes. Something with geodome printing or the ability to come in. Because one of the things I'm thinking about is, where might this go in a couple of years? Maybe you have like a FEMA response team, or maybe you have something through Fort Bragg or something like that comes in and is able to bring in 3D printers. How would you see those 3D printers being able to support people during, I guess within hours or days after a significant crisis situation?
Yeah, you could 3D print, and it's probably better crowdsourced. It's instead of having FEMA come in, unless you have, like a cargo container and you have 30 or 40 3D printers in it, and that could be a thing. You have 30 or 40 3D printers in a cargo container and a generator, and you're 3D printing couplings to build a geodesic dome. So I've seen people, they designed, I think it was on Thingiverse, couplings for extruded metal conduit to make 3D printed geodesic domes. So you have metal conduit, you can use viscreen plastic or something else, or actually getting a little more creative, you could use canvas and spray concrete on it and then have a very permanent structure that's super strong. And geodesic domes are a big deal because they use the least amount of material to cover the maximum amount of space. So it's very cost effective. It's also, because it doesn't have any corners, it doesn't radiate heat, so your cooling and heating requirements are quite low, and your wind resistance is really high. They even use it on aircraft carriers. Like if they need a structure on the deck, they'll pop up a geodesic dome.
That's amazing. I didn't know that. Okay.
Yeah, I'm a big geodesic dome nerd.
So geodesic. So imagine, okay, and you also talked, Rich, about something with antenna, 3D printing antenna,
Sure.
and how that is it. Are you talking about shortwave communications or like a repeater, or I guess when might the scenario play out?
Yeah, an article I shared, there's a bunch of different ways of doing this. So like one of the issues when Puerto Rico was hit by the hurricane, it knocked out power, communications, etc. So it's funny when you talk to somebody like my daughter who's 19 that like, how did you talk to your friends before cell phones? It's like, kind of like a blank stare.
I remember that. Yeah.
It's like you knew they were home between this hour and that hour. They got off of work. You knew more about them and remembered more about them, that you were able to reach them on the first call as opposed to the fourth or fifth call. And before there were answering machines also, right? Nobody even knows what an answering machine is now, and what a big boost that was.
Right. When I was in college, Rich, so my roommates and I, we used to do like, whatever the answering machine was, the 30 seconds you had to, for the message. We used to do a whole production. So people would call our number just to like hear the message. So if we answered, they'd be like, hey, like hang up again. Like we're just calling to hear the message. So like we got really good at that, like doing these kind of like skit type things. So our phone was always ringing. But the old how that was with the answering machines. So please go on.
Yeah, so there's a lot of interesting things out there available to us now, and I think it's really just limited by your imagination. I haven't done any like lost PLA processes, so I always wanted to 3D print something and do a lost PLA process, and either cast it in aluminum or bronze or something like that, and make a part from it. Just kind of as a mental challenge. But I do think it goes into like, hey, I'm not relying on a supply chain if I can manufacture something. So whether it's desalination, whether it's a mask, whether it's a geodesic dome as a structure, like they talk about 3D printing concrete, it's
Right.
not an. I'm sorry.
No, right. Like I've seen that on some homes now, right? 3D
Hmm.
printing homes with concrete.
I think Habitat for Humanity had an article recently that they 3D printed a home, and so the first concrete 3D printed home was given to the homeowner.
It's amazing. That's amazing. Okay.
So it really is like, this is a part for the pool vac, and I'm like, could I 3D print this part? Now these are stainless steel collars. Could I replace it with like hobby store brass and use that? So it really, you have to understand what the materials are, what the material life is, kind of the wear on that material, what you can get away with. And I think we're going to find more and more things that people are going to be manufacturing with 3D printing, and using, I would say, more composites. So I don't think the answer is always, like I said earlier, to 3D print 100% of one item. Maybe it's like you want a microphone stand. Maybe you don't want to 3D print the microphone stand, but some thin tubing or some carbon fiber tubing with a 3D printed end with an eye on it that bolts into another part is the right way to go. People that have sheet metal skills or welding skills, they'll be more inclined to like, hey, take some parts and use a metal brake to bend a complex part out of a sheet of metal, and then weld other parts to it and make something more complex that way. Like that is more of a skill. 3D printing is relatively easy compared to like welding, learning how to weld or CNC machine something. And the ability to do something like 3D printing, and people talk about legislating 3D printing, and I think the reason if that is because a printer is $200, it's not a really super high skill level to be able to work one of them, whereas CNC machining, the machines are $100,000 and it requires a lot of skill to be able to do that. So I think that's why governments are getting involved with like legislating ideas on 3D printing.
It's a good point, because one of the things that we talked about before too was 3D printing of things like limbs, for people, prosthetics, for example, could be. And I think the part you hit on, Rich, which is very important, is instead of one person coming up with all of these ideas, it can be crowdsourced, which we saw during the relaxation of intellectual property protection rights during early phases of the pandemic back in March, April, May, when some of these things like mask ventilator parts that had been copyrighted or trademarked were available for people to 3D print and then distribute to their local hospitals. But this is amazing, to think, how everybody can come together and contribute to this. It also is going to change. So I teach school, legal issue courses, and one of the things that has come up in the last 2-3 years is, schools are revamping their industrial arts, quote unquote, labs to be, 3D printing, CAD design. And as you said, this not only that you're working in kind of a solo function, but you're working as a team, and that team might include someone from Connecticut, someone from Honduras, and someone from, Indonesia and India and whatever, and you're coming together and to create these things, which I think is amazing. So have you personally and I put in here from B3 Outdoors, 3D printed tibia bone if a shattered leg, right? I mean, the medical sector, this is going to take off.
Yeah, there's, I saw, this might be years old now, articles about 3D printing organs, not complex organs, but simpler organs, that you have the components and you could actually 3D print them in a lab.
Wow. Wow. Yeah. So I mean, so if we think about, so what is your thought, Rich, on, in my perception, I guess, why 3D printing hasn't received more, I guess, media coverage, or why the media coverage of it is typically, oh, you're 3D printing, you're making a ghost gun. It's negative, and I heard that again today. I heard 3D printing, and the next breath was the reporter saying this will contribute to the production of ghost guns, ghost weapons, ghost whatever. And so there
So
is this strong stigma that 3D printing has to fight against, right?
yeah, that's a whole hour's at
Right.
least of another show, because there's all sorts of, not just the I can print this, but there's the, let me first off, if you're a criminal and you want a gun, I don't know that you're going to buy a $200 3D printer, learn how to use it, and then order all of the parts to print a frame of a gun, and then order all of the parts, and then understand how to assemble it. That's kind of a higher level skill set. And if you're that good at those things, I don't think you'd be a criminal.
Right.
So
Right.
it, and I think the whole idea of the 3D printed gun, I'm a criminal because I don't want to go to work or I need more money, and it's probably easier for me to buy somebody's stolen real firearm as opposed to 3D printing a firearm. And the other part of that is I've done it. I've gone to a hardware store, I've bought a couple of pieces of pipe and a roofing nail, and I've built a shotgun in under 30 minutes.
Amazing. Yeah.
So I think it's kind of pigeonholing the idea that I'm a legislator and I'm going to regulate 3D printing because you can 3D print a gun, is kind of a stupid idea. I think it's one of those things. One, it's a marketing idea. Listen to me bloviate about how I'm going to make you safe from these evil 3D printed guns. You're going to be no safer. And I firmly believe evil will find a way. If you look at homicide rates in the US versus homicide rates in Europe, or let's take England. England has higher homicide rates. The difference is they beat you to death with hands and fists or knives.
Right.
So it's actually worse in England than it is here, the homicide rate per thousand.
Remember the day of the Sandy Hook shooting in America, the massacre, and that same day, because I did a PBS presentation, there was also a school violence via knife incident that happened in China, right? These things weren't covered.
Yeah, it was like 20 something people injured at a train station, if I recall, if we're talking about the same incident.
So yeah. So I think it is this aspect where, and especially, anytime I can enter into the narrative with it, is it seems so closely tied through the media of 3D printing of being a negative thing, that we're going to have all these things that come out that are regulated, right, that should be there. And again, we're talking about, now you're sharing about it, the positives of 3D printing, which I think are phenomenal. And also I think people are uncomfortable. They're uncomfortable to move from this just-in-time manufacturing to 3D printing. So it changes always uncomfortable, especially now. The pandemic, I think, accelerates that. So, but I think part of the purpose of the show is to identify and let people know what the capabilities, which we've done, 3D printing, and then also 3D printing in a disaster situation is an immeasurable asset. And especially if we put a little bit of thought to that. I don't know. Again, I mentioned FEMA, and some people say, yeah, if you see a FEMA sign, run away. Ting Ting said that. And I know FEMA has not been as reliable, for example, maybe as Cajun Navy Relief, Cajun Navy Army, Texas Army. But yeah, these organizations are going to implement and figure these things out. So I'm thrilled. I am thrilled. So where do you see in the what is, I guess, something you want to accomplish in 3D printing in the next year? In 2022, what
Hmm.
is something Flying Rich wants to accomplish
Wow.
with his 3D printer?
Wow. I actually haven't thought about that.
Okay.
Um, I want to hit on a question somebody asked a little while back. That'll give me a little time to think about what
Yeah.
do I want to accomplish. And so, who is Abhishek said, is there a neural network like GitHub's Copilot for engineering? So it's easier for the GitHub Copilot. And for those of you that don't know what Copilot is, and when I initially read this, I didn't realize what he was talking about. Copilot is basically an AI code completion, which is easier to do in software because you already have established a number of variables and there's a number of functions and methods that you're going to be doing in software that AI can really help you with. I've never heard of AI working with 3D design. And, maybe there are ways it works. I'm not familiar with it, but maybe you're designing an intake manifold for a carb and you have, fluid dynamics that you're going to be dealing with, and that could aid you with it. But I'm not sure, like my simple, hey, I'm designing a mount for my TV, and the mount is basically bars I'm going to bolt onto the back of the TV, and it's going to look something like this spacer that is going to stand off the TV from the bar, so I have clearance where it's going to mount. But I don't know that AI is going to hit on something like that, but maybe if you're going to design something and then run it through for efficiency, say, I printed one of these at 60%. I printed one of these at 10%. The one that was 10% broke immediately, and it's this one because I used crazy glue to put it back together again. Maybe if I designed something like this, my TV mount, and said, well, it has to, here's the criteria. I have this high of a compression load on it. I have this high of a tension load. These pieces are going to be designed for one use only because it's just a jig. So maybe it could have been narrower, and the AI could have said, okay, with these constraints, a small part like this, you might want to do 100% infill only. If it was larger and taller, you might want to do it with 20% infill, but more shells, more inner and outer shells on it to make it stronger. And it might do, right now, it automatically does, when you run it through a slicer, it automatically varies the mesh infill. So it gets denser when it's a smaller area and it gets larger.
Okay.
So there is already a little bit of AI in that. So not exactly answering the question that was back there. And I'm sorry if I missed good questions in the chat here, because I've been trying to pay attention and
No.
stay on point here.
Yeah. No, we have a terrific group here in the chat, and they always have very intellectual questions. So I'm also not able to
keep up with the chat, right?
Keep up with them because they're just so vibrant, going back and forth. So someone asked a question about like graphene filament. Like, do you anticipate, because the properties of graphene, what are like 6 times stronger than steel, and much lighter and stuff like. Do you anticipate like this is going to be?
So there's like carbon infused filaments, and there's like carbon, Kevlar, you name it. There's wood, and I've never tried a wood impregnated filament, but apparently the wood filament, you could print an object. Say, I just had this happen in my house in New York. Is it a spindle, the vertical parts of a stairway? So my house is probably like 118 years old in New York. And so one of the spindles was broken.
Wow.
I could have maybe, and I brought, where is it? Another prop. So here, typically use this in automotive type stuff, automotive applications. You want to like match the shape of something. So maybe it's the right fender, you want to match the left fender. Well, you could push it on, and let's see. All right, I'm doing that badly. But you get the idea that you get the shape of something. And I could have done that with the spindle. and then drawn the line. I've actually done this before. I got to remember what I did it with. So I traced something on a piece of paper. I put it through the scanner in my wife's office, because she does more office type stuff in her office as opposed to 3D printing stuff.
Okay.
And so I scanned it. I brought it into GIMP, which is it's a free software like Photoshop. Cleaned up the line, traced it. Oh, I know what it was. I'm darned. That's one of my best 3D printed items I have. Most functional items. Let's see. Do I have it close by? It's over there. I can't get at it right now easily. So I remember the part. It was a latch to a Pelican case, but the Pelican case I bought like the Harbor Freight knockoff, and the Harbor Freight knockoff Pelican case. And if you look at my channel, you can find it. So I pulled the Harbor Freight Pelican knockoff case latch off, and I traced it on a piece of paper, scanned it, imported into GIMP, which is like Photoshop, but it's free. Cleaned up the lines a little bit, did whatever special sauce I wanted to do to it. And what I wanted to do is add a way to make it a locking latch, because the locking case was much more expensive, and I wanted to fly with this case and put a lock on it. So I redesigned it, and I actually put like knurling on it so it was textured so your hands didn't slip off it, and it was better than the original. I 3D printed it and a test in a drill jig to drill the case so the lock hasp would go through it and lock it. And I don't know that I uploaded that to Thingiverse, but again, I got to be better on the sharing back out to the public. But yeah, so there's super cool ways of, utilizing many different technologies. So I utilized just simple tracing, scanning, GIMP, which is free Photoshop, exported it as an SVG, imported into Tinkercad, extruded that, did a little work on it in Tinkercad, and then brought it into Cure, which again free software, and 3D printed it. And then the latch, boy, I do have some samples of the latch. So the latch was, say, this wide, but I printed just a short section of the latch. Instead of printing like 3 inches of the latch, I printed 3/4 of an inch, and with like light infill, so it printed fast, so I could test it. That like, hey, will my idea work? And it did. And I'm like, okay, let me go for 100% infill in the full width of the latch. So there's some cool things. Maybe one of the things I'm looking for with 3D printing and my goals is I like to make things simpler for myself at home. Like whatever I can do to ease some of my things. So if I have a case like this for my microcontrollers or Raspberry Pis, and it's aesthetically pleasing, and it's not a wiring nightmare. Like I have a bunch of those things running the home automation controller, and I actually have AI running on my home network monitoring my 8 cameras. And those are all single board computers. So I have kind of a mess, and I'd like to organize it and maybe make it so it's not hidden behind a couple of doors, that it's aesthetically pleasing. I do like the idea of doing some sort of hydroponics and maybe growing tomatoes. And if I could do it in a visually pleasing way, let's see. So GIMP is like GNU, which is the open source foundation. So GNU Image Manipulation Program, I believe, is the acronym. So, sorry, let's see.
So your thought is these things will persevere, like they're not going to be wiped out by the government.
I think there's a lot of topics that politicians get political traction on, and everybody says, yeah, them 3D printers and ghost guns are evil, we got to regulate that. You make that law, I'll vote for you again.
I hear that a lot. Yeah.
And so I think there's a lot of that going on. I think it's like, and I don't mean to make fun of nuclear physicists. A nuclear reactor is just some thing that gets hot, boils water, turns a turbine. And it's just a little different than a steam generator that uses fuel oil or propane or something else to to make steam, to turn a turbine, to turn a generator. But people get all nutso about nuclear reactors because they don't understand them. And I don't think a 3D printer is some new technology. I don't think it's tough to understand. But I think people are easily, riled up about something. And when you think about drones, or I'd rather say quadcopter.
Okay, quadcopter. Got
it. Because you've seen videos. I've seen videos on the internet of, young kids, teenagers, getting beat up by people because they're flying their quadcopter in the park.
Yes. Yeah.
And it's like, you don't have a right to beat up that guy because he's flying a quadcopter. I've flown model airplanes for years, but nobody was ever upset about a model airplane. But somehow they're upset about quadcopters. Because, typically you have a camera on a quadcopter,
right?
A drone.
Well, it's amazing because I did 2 shows on quadcopters, right, or drones.
Mm-hmm.
And I interviewed Preston Rice, who was a commercial drone owner in my neighborhood. Like, he's a couple
Mm-hmm.
blocks from me. And at that time, he professionally went out and inspected like power lines and
Mm-hmm.
windmills and stuff like this, and was talking about how that process worked. But I also talked about it in my school legal courses and said, what if you had a drone operator, right, or a quadcopter operator from your area who was able to come in and help you with a search for a
Mm-hmm.
student with autism who wandered away from campus? Like, what might that look like? And would you allow that person to interface with you? And it's interesting because people are like, well, I don't know about that. We've never talked about that. It's not in policy and things like this. But there's so much, right, that is available in these areas that we're not even thinking about. I remember I had my property surveyed back last year, and the surveyor, threw up a drone at one point, just to get, whatever it was, mark some points and things like that. And I'm like, holy
Mm-hmm.
smokes, that's pretty cool, but yeah, I think I think there is this entire public relations
Mm-hmm.
disconnect between 3D printing and then also quadcopters. Because the first thing that came to mind, honestly, Rich, is you mentioned quadcopters. I was thinking, people are out there and they're trying to do surveillance of other people and stuff like that.
Mm-hmm.
Really, and that's not true, right? That's just, but I think, we have this whole disconnect against face validity. It's like, how are people using these things? And if you have a 3D printer, well, you're doing something mischievous in your basement.
Mm-hmm.
And stuff like that. And if you have a quadcopter, you're flying and you're watching your neighbors, right? And you're taking pictures of your neighbors at their barbecue and stuff like this. And that's just not true. But we don't really, I don't know, in my experiences, we don't have the positive, or not even the positive, but the realistic side of that comes out through the media, maybe even through these organizations, or it gets suppressed, I guess.
Sure.
So if I were to go out and take 20 people on the street and I was to ask them, your thought about 3D printing and your thought, whatever, I'm guessing the majority of those would be negative impressions.
Probably.
And I think that's a huge flaw. So I don't know how to counter that, or what your thought is.
I think of, all right, so in the United States, we mainly use hammers to hammer nails. In Europe,
Yes.
or in England, they use them as lethal devices. So let's go at the interface of where horse and buggies were disrupted by this evil thing called the automobile. And when you think about all of the onerous restrictions that were put on automobile owners at the time of the horse and buggy, and I think a lot of it's because of, just jealousy. You could afford one of those, or why would you do that? That's obscene that you're doing that. And let's go forward a little bit. You can use a vehicle, like a car or truck or whatever, offensively, or you could use it to save somebody's life, like an ambulance. So there's,
right.
I think there's evil in people, and you're not going to legislate that out. And you could just as easily use a car to take somebody to the hospital as you could to injure somebody with it. And it's up to the person operating the vehicle.
It's a great point. Yeah, I, I'm so Rich. I mean, I've learned so much tonight. One is the capabilities of 3D printing, and also the other part is the cost. Right? When you said 75-watt light bulb, for the device that you're running, and I'm like, okay, that's it's not very expensive. And then this whole thing with open source, I guess, right? And I saw that, I wrote about that in the Velocity of Information, how thousands of people came together to share information about how to print ventilator parts and so forth, and printed those and distribute them. And that was a legal precedent, right? There was if I go back in the book, I'd have to find it, but there was some legal time frame of 180 days or something, where copyright was basically removed from these items, and you could print these without ramifications of possibly being sued. I think there's this amazing greatness of humanity when that happens, and how that can scale. And then we talked about too, and you brought the information with the antennas and the domes, for example. After a Sentinel catastrophic event, the Kentucky tornadoes or the Superior, Colorado wildfires. So this is so. Let's kind of wrap this up with, if somebody is interested in 3D printing, but they're like, oh my God, I'm not a tech person, I don't know, this is overwhelming for me. Like, where do you think they should start? Like, if you were to advise somebody who's kind of new to this, what would you say? No, like, here's your first steps into this.
There's so many good YouTube channels on 3D printing. Thomas Sandeladerer, and I'm probably butchering his last name. I think he's Swedish or so, but it's an English channel. And he has pretty much anything you want to know. Like, you can type into YouTube, like, what 3D printer should I buy? What is the best 3D printer? How do I get started in 3D printing? There's a stink load of resources on YouTube. There's also groups of people out there. I've probably learned most everything I know from YouTube on 3D printing, as opposed to interacting with a group of people. I used to do a 3D printing podcast on the Podnuts network, and there's a few guys there that I still keep in contact with. Some print professionally, so they have a print shop basically, and they're 3D printing items for people. So yeah, there's a lot of good resources out there, and I'm sure there's groups online you can find. I just haven't partaken of that.
And so, if someone was to start out with this, what do you think the outlay of cash is? Like $500 to get them?
Oh, no.
Okay.
So you probably, for sub $200, can find an Ender 3, and I would highly recommend the Ender 3.
Okay.
There's a couple of modifications I like. Let's see. What is the tube? I replaced the Bowden tube on it with a higher temperature tube. I forget what it's called. I'll remember 10 minutes later. There's a magnetic bed that I like. So two $10 upgrades on it. So, and a couple of spools of filament. So PLA is the filament that everybody mostly uses, and I'd highly recommend PLA. So for under $300, you could get going, and easily for $250, you could get going 3D printing. I would recommend, so all of the software that I use is free. So Cura, which is the slicer. So, and we kind of didn't talk the high level. So if you want to design something on tinkercad.com, which is free, you just set up an account. You export your STL file, which is a stereolithography file, to something like Cura, which is the slicer, and it's multi-platform. Cura works on Mac, Linux, and Windows, and that's free. And yep, Tinkercad. I embarrassingly do all of my design work on Tinkercad. I'm at the limits of what Tinkercad will do. And I did a live design session last night for the TV mount on Tinkercad, just showing my screen and how I did the parts, how I designed the parts. So Tinkercad really is designed for kids, but that's actually what I've been using, and I'm really good at it. At least I think I am. There's probably somebody that'll kick my butt. But there's Fusion 360, and I think there's like student licenses for that. So there's better software. So pretty much there isn't any software you're required to pay for to get out, doing it. It's really the physical items, the printer and the filament, that you need to buy. Tools you probably have around the house. You probably have, a razor knife, some sort of X-Acto knife, sandpaper. If you're gonna, just work on finishing an item, your 3D printers come with a couple of tools. So to cut the filament, when you 3D print something, you might have support material that you have to clean out, and just some needle nose pliers or something like that is pretty much all you need. So easily for under $300, you can get started 3D printing.
Okay. Wow. Looks like somebody tried to 3D print the engine in my Buick LaCrosse right here. So check that out.
You'll definitely find things like that. I actually 3D printed a Torsen differential.
Really?
Because,
oh my God.
Yeah, I never fully assembled it, but it took a couple of days. I 3D printed all of the parts on one sheet, and some of the dimensions were a little off, and there'd be probably a number of days of finishing and cleaning up the parts to make them work right.
Holy smokes, that is amazing. Wow. So yeah, this is incredible. And again, specifically, Rich, as we talked, I wanted to understand the capabilities of 3D printing because, again, I was more of, home 3D printers were at a record sale for this Christmas. I'm like, people making articulated robots and flutes and stands for their phones and stuff like that. But I didn't understand the whole capability, the wider range capabilities, which are becoming more mainstream. And then also, of course, working in the area of safety. And what does this mean for safety, right now? And also, what does it mean for rapid scaling of production after a sentinel event, whether that be a wildfire or a tornado or something like that? And yeah, I remember I was brought back to a discussion I had with Katie Pichon of Cajun Navy Relief, maybe 4 or 5 years ago. And it was after Hurricanes Harvey and Irma. And she stated one of the frustrations of people in Cajun Navy Relief who are commercial drone pilots is they would bring their drones into locations, but they were forbidden to fly the drones because, whatever local regulation or things. And they say, if we can fly the drones, we can guide the boats, that we brought into where they need to go. And we can also watch for, dangers and hazards. We can observe if there are people who are under roofs or whatever who need help. And of course, like the policy just hadn't reached that capability yet. So they're saying, now, if you do that, like it creates a liability if you show like a dead body, for example, or, but that is kind of modified, it's adapted now. It's adopted, right, where you can bring 3D drones and it's become part of their force. And I think it's the same, or not 3D drones, but to bring drones in. But I think 3D printing is right there. It's like, I believe you will have rescue forces that will have 3D printed, capability that will come into these zones which have been devastated. And what they provide, I'm not yet sure. Like you said, it could be domes, right? Because it makes sense that you could rapidly make those. It could be antenna.
It could be something for water filtration, water purification.
Absolutely. So, I mean, we could come out with a list of maybe 5 things that could rapidly scale through if you could bring in like this 3D printed, capability into this area, which is phenomenal to think about. And I also, I get so, I don't know, I wouldn't say perplexed is the word because I don't think that's accurate, but I'm frustrated sometimes, with the mainstream media and when they don't talk about these things, right? That we're not only close, but we need to embrace this, like after the Kentucky tornado or after the Superior fires, that we need to embrace these technologies, and people who are willing to be the kind of the frontier folks on these technologies and how to interface them to support people who have been devastated by these horrific events, and not to stand in their way, right? Not to make some kind of bureaucratic steps that you have to go through. That was the thing with Cajun Navy relief. Like they were saying, well, you have to be registered and you have to do this and that. And it's like, well, the bottom line was you have a community of 2,000 people, you have one boat and your community's flooding. Do you want us to come in and rescue people or not? So
right. And that was the amazing thing. I don't know when the Cajun Navy became an official thing, because it was just a name thrown at a bunch of guys that showed up with their boats to help. And I always said the Wright brothers didn't wait around for the FAA to give them a pilot's license; they just flew.
Right.
And I think that's kind of an American thing. I think that's like, we're not waiting around to get the permission to do fill in the blank. We're just going to do it.
Right. And I'm with you. And I think, 3D printing has so much to offer in so many realms that will be remarkably positive. And also, as we look at, having to, transfer goods from one location to another, and the cost and expense and time and stuff like that, with the ability to just possibly 3D print it on location. So much of this is going to be positive. So that's one of the reasons I wanted to do this show, is to come back and also to benchmark this show and to say there are so many positive things with 3D printing. Not only that, just to champion it, but to say we are already in this transition from just in time to 3D printing. And also from a safety perspective, 3D printing is amazing. I mean, think about, Rich, like 30 years ago. So in my hometown, which is northern Wisconsin, 30 years ago, they received a new fire engine, right, which they spec'd out and everything. And one of the big things that they did is they said, we want this fire engine to be well equipped for fighting chimney fires, because people in that town at that time, back in 1989, there were a lot of chimney fires. So that was a big thing. But right now, with this truck, so they ordered a new fire truck, which will be delivered in 2023. And the fire truck, though, needs to be compatible with. So actually, there's a side compartment in the truck. I saw the design that has a drone. It will come equipped with a drone, just as part of the engine, and then also equipped with special, foaming equipment to fight an electrical fire if it's a vehicle, electrical vehicle. So these are, in 30 years, right, the technology shift in the thinking.
Oh, for sure.
But, who would have thought and who would have embraced this? And again, I really admire the work that you do. I love your channel and how you're like, I do. And how you share things like, I'm working on this project, or, I watched the whole pool video where then the vacuum went down and it was going around and stuff like this. And I'm thinking, but that's really cool, because that's self-sufficiency. And that is something which doesn't make us dependent upon, massive companies or, overseas or so forth. You can get people together and you can CAD design, or you can modify, and you can make these things. And it just is a self-sufficiency. It's a sense of agency and purpose, a control over your environment if you're able to do this. And I loved it. And I thought, even if that bearing would have failed, like, you would have figured it out, right? Because you'd have been like, material, or the pool's going to.
The first one failed in a couple of weeks, but it was because I used, and it's funny, one of the other 3D printing guys I know, like, oh, I used PLA, yeah, that'll absorb water, that's not going to last. And, he's like, print it in PET G because that's what water bottles are made out of. I'm like, okay.
That totally makes sense, right? To print it out of that. So it's just trial and error, and then you share that back, and it goes back into some open source, and so I am very optimistic about this right now. And this reminds me of a feeling I had, maybe, I think it was 3 years ago. There was a company called What 3 Words. It's still in existence. What 3 Words, based out of England. And what they did is they broke up the entire surface of the Earth into 3x3 foot, squares, basically. And they assigned a 3-word definition to those, right? So I might be standing on banana marathon stop right now is where I'm at. So if I put that in, emergency responders would know exactly where to respond. So it's used in the UK, it's used in Finland, Sweden. The US has used it for Super Bowl management, talking with ISS 24/7, and it's being adapted, I think, into Mercedes-Benz and Ford in 2022 in their vehicles. So you would just need to use these 3 words, but it was this technology where, you would think that's crazy, like, this wouldn't catch on, but actually it does. It makes a ton of sense. Like, also, if you're out somewhere, it could be anywhere.
It's much easier. I'm like, well, you have to have GPS coordinates to do that, but humans suck at GPS coordinates. And instead of giving it, like, are you giving it digital, or are you giving it minutes and seconds? Because there's like 3 different formats for GPS coordinates, and to get down to a 3 square foot level, you're going, I don't know how many digits into a GPS system. But that is smart, because while you're talking about that, I never heard of it before. I'm like, well, we have GPS for that, and I'm like, ooh, not exactly that good.
So one of the things that would happen, and so what 3 words was big in the school safety community when I started to talk about it. So let's say that you had, let's say that you said, "Hey, everybody, so Rich, you're in Florida. Meet me in Miami at the stadium. We're going to watch a Dolphins game." So the thing is, like, people will be like, "Okay, like, I know how to get to the stadium, but I don't know how to get to where
Like
you are
gate
at
F.
tailgating right now. Rich, you've got the brats out. You've got the beanbag game going. Everything is going great, but I don't know where you're at. There's like 70,000 people here, and you can say I am at memory stop second, and you're like, okay, you type that in, and it will geosynchronize you to that exact 3x3 square on the face of the Earth. So it'll take you right to your vehicle, right to where the tailgate is. And that was actually how they came up with this. I interviewed the one of the founders of what 3 words. We talked about this. Why this was necessary, and he said it originated off of like big venues. People would come to big venues, and they wouldn't be able to figure out like where other people were at, how they could meet them. Yeah, I'm here at Yankee Stadium.
Oh, for sure.
At the Astrodome or whatever. It's like, oh, great. Like, right, this is 10 acres and there's 100,000 people here. How do I find you? So, so that's pretty fascinating. And so it's kind of where I try to think of things. And now I think more of 3D printing. And, I also look at, I've talked to some people in the firefighting community. Firefighting equipment, if you maintain it, can last 30, 40, 50 years. But they said the hard part is to get parts for it, right? But what if we could manufacture some of these parts? You could have some of them machined, which is very expensive. But what if you could actually have some of them 3D printed, or through a cooperative, which would maybe volunteer work, their time and effort, and say, we're supporting XYZ fire department so they can keep their pumper going for another 5 or 10 years. And we're crowdsource this.
And so let's talk about that. Like you mentioned, there's two sides of the spectrum. Like there's John Deere, and then there's open source. Like, could there possibly be an open source fire engine where every part is like, you have it on a thumb drive? It's like you need bearings. Well, maybe you're not going to manufacture the bearing, but you could get a 6202 from Timken, and you can just order it. Like, it has the part number, but maybe the spindle for the axle, you have a spec for it. It's going to be a certain alloy of metal, and you machine it with this process. Or like maybe it's you can go to a CNC machine shop and give them the thumb drive and say, hey, I need 2 of these axles machined, and they can do it for you. It could be something like that. Or the model could be the John Deere model where you can't change the oil unless my dealer does it and pushes the certain button a certain way, and then your tractor will run again. And after 20 years of that, all of a sudden it's open source, and then you can do it all yourself.
Right. That is amazing. I never thought about that as being a viable option, but you're right on. Right
Mhm.
on. So I think there's a part of this too in the safety community that um, you know, lends itself to an extension of viable safety equipment, which again, people, it's just not supported because the manufacturers have moved on and they said it's beyond 20 years, so it's
Sure.
obsolete. And they're like, well, it's not really obsolete. Like we can still use it, but we need these parts. So I think that's a whole other piece of this, which is just incredibly um, and here, Solitude Surfer saying, I love an open source fire engine. Damn, this is a lesson. Thanks for well, thanks. Well, I appreciate that. Vanessa, bomb each other's yards, a battleship mini. Whoa, I don't want to. I'm not willing to start a war with my neighbors. I like my neighbors. They're good folks.
Right. Is that with quadcopters or trebuchets?
So yeah, and an interesting thing here with quadcopters is, so I have a video taken from the Bellevue, Washington Police Department from their website, and it was back in March of 2020, and they were asking people to report social gatherings which were larger than 4 people, and you could take photos, right? And what was happening, and so like I documented all this from their website. I did like a 45-second video of it. It's in my book and stuff like that. They've taken all of it down, right? It's a 404 now if you search it. But what was happening is people from out of town were coming in like with drones and trying to like capture people and report these things. And it was just
Was there a bounty?
There wasn't a bounty. It was just this thing.
You didn't get like a PayPal, like if I report these people, it's like, safety dogs having a barbecue.
You're right. And the thing is, like, you could submit pictures. So there was.
Well, they did that in New York. They did a snitch line. I forgot what it. Oh, what was it? Oh, yeah. This went south. I think you were submitting pictures in New York to Bill de Blasio's office, and anatomical portions of people's bodies were getting submitted.
Whoa. Well, the thing is, I don't know whatever happened to these photos, right? Because we had it happen nearby us in one of the communities. And I said, that's going to be a legal problem for when there's a request for freedom of information, photos. And have you modified the metadata, right? Have you tried to just screw your neighbor over? I mean, just so much was wrong with that approach.
And I could Photoshop a whole bunch of people in your backyard and report you.
And then and then the responsibility or the capability of the police department to identify that this has been a modified photo, and what, can they do that, or do they just initially issue you a fine? And so these were huge things, and quick. It was about a month, and those kind of dissipated because I think whoever the legal folks advising these cities and municipalities, they just said don't do this because
right. It's a big can of worms.
It's a big can of worms, and oh my god. So let's get into the final questions here. Rich, this has been phenomenal. I've loved this evening. I've learned so much. Vanessa wrote, okay, when my wood-fired oven is baking breads outside in early AM during pandemic shutdown, my neighbors would be at the fence. I don't know, Vanessa.
So, I have said on frequent podcasts, I wish Vanessa was my neighbor because we would have a stink load of fun.
I think Vanessa's awesome. Yeah, I agree. And I'm in cold weather Wisconsin area, so, and I know she had spent some time in Alaska, so I think she would be right on board here. So yeah, well, Vanessa, if you ever want to send some baked bread here, let me know. Contact me through the network, and I will definitely give you a PO box address because I will not turn that down. Man against a man. Oh my goodness, bacon. So Vanessa, I will 3D print effigies and stand them in your yard and snap a pic. Yeah. So yeah, to report people. That was really just a bad.
That's interesting.
A bad idea. It was one thing, Rich, that actually my publisher would not allow me to put in the book. So out of all of my images, I had a screen capture of the Bellevue, Washington city website when they released their tool to report other people. And they said, yeah, let's not include that.
Was that Karen.com? What was the website?
It's funny because I do have it still on my Twitter. I made a 45-second video of it where I actually went through like my portal and all this. Like if you were to report your neighbors, you drag a Google map and in pictures and description and stuff like that. But yeah, Bellevue took that off, and my publisher was like, yeah, you can
They
describe
memory
it,
hold
but
that. Yeah.
let's not put the photo up there. And I was like, okay. So Bolo, our good friend Bolo here, is saying I can smell freshly baked bread. God, I love bread. I have my roommate in college.
And he had a comment earlier, can you 3D print me a post hole digger? And I'd say generally the answer is no, unless you're doing sintered metal. But if you're doing plastic, you could print the die to bend the metal for the post hole digger.
Holy smokes. Yeah. I grew up on we had what's called a ginseng farm. I don't know if anybody is familiar with that, but and we had post hole diggers where we would manually dig and put into posts.
Like which one? The ones where you operate like, okay.
We also had, ones that were driven off of the
auger, off the PTO.
Off the PTO. But I made a number of those by hand. My dad and I, this is a true story. So my dad and I, back in around 2006, circa, we with a post hole digger and just post, right? And axes and saws, we rebuilt 200 feet of fence at Fort Winnebago, which is in my hometown. It's a fort from 1824. Jefferson Davis was actually assigned to the fort as a 20-year-old. So yeah, Jefferson Davis. It's about a mile and a half from my house. And my dad and I, with postal diggers, and we took a couple days and we totally rebuilt this fence. And we also rebuilt a well. And to this day, it still stands. But it was kind of interesting. Cool. It was. We volunteered our time and materials and all of that. And I was a volunteer guide at this fort, and this fence had been in disrepair for probably decades. Most of it had been down, and so yeah, we built this. And actually, I did it where from the outside you could not identify that this thing was bolted together, right? Like I used leg screws and everything, and it was really this thing was solid, but it was a great experience. I mean, it was fun to work on that with my dad. It was fun it was meaningful to donate that to the city, to clean up the property and to do that. I can imagine with a 3D printer, the stuff I could have done maybe with the well, because there were some really crazy brackets I had to try to maneuver and manufacture and stuff on this well to there's something interesting. It's not for this show, but like even historic preservation if you have the ability to 3D print, because I was given the role of kind of like the historic curator of this building from 1824, just because there wasn't a budget. And so if I could go up there with my tool belt and stuff and, work on shutters and things, which, probably shouldn't have happened, even though I kind of know what I'm doing. But I'm like, holy smokes, like there's so many things I think that I could have done if I would have had a 3D printer and some knowledge.
So even in woodworking, 3D printing jigs and guides and like center finding devices, you can 3D print simple things for angle finding, measuring. There's one of the cool things, like if you ever look at a historic building and they have all these beautiful wood carvings on the trim or molding, you can actually 3D print that, something like it's not feasible to pay an artist to do that, or you can have a CNC router. Now here's even cooler. So we're kind of going on the wind down now. We're ramping up again. The guys that I was doing the podcast with on 3D printing, there's an MP CNC, and that's mostly printed CNC machine. So it's you 3D print all of the parts to join, tubing like this together for the rails, where you would have a CNC router mounted. And you can Google MP CNC and find the project. And you could build a CNC wood carving setup. So the ability to, and one of the things I didn't mention earlier, it's favorite line of a buddy of mine that bought a 3D printer when I did. He's an architect, and he wanted to be able to like give people a 3D rendering of what he was designing. And because you can 3D print parts to build other 3D printers, he said, it's incestuous because it makes its own parts. And I've done a lot of that because I've modified, upgrade parts on my printer with things I've 3D printed.
Holy smokes. That is amazing. I didn't even think about that.
Oh yeah.
Oh my God. That is wow. Wow. It looks like Vanessa has just offered me some bread.
Ooh, I'm jealous.
I will certainly accept. So yes, I will never decline that. Yeah. So, well, Rich, I want to, I want to respect your time, and we've had a terrific show. This has been, for me, extremely informative because I will take this information, and as I go on and instruct my university courses, as I do my other work, I will incorporate this. I mean, in the community, right? As we talk about, 3D printing, and I think more broad, multi-optical perspective of what 3D printing is and where it might be going, and then the whole thing with school safety and community safety of 3D printing and where people aren't thinking right now. What is the capability of 3D printing and how that could be an asset after a Sentinel disaster event. I think these are things which are very relevant right now. So, and again, as I've tried to point out in my book, we went from warehouse manufacturing in the 1980s to just in time in the 1990s to early 2000s, and that model kind of went. And now we're into 3D printing. And so, my perspective is a lot of what people are experiencing right now with the supply chain and all of this and whatever, there's a missing part of that discussion. That's the part of we are transitioning rapidly to 3D printing, which is a very good thing. But we don't hear that on the news. It's not David Muir, ABC Tonight or whatever, talking about that. Hey, this is happening right now. And so I think people become scared. They become apprehensive. They feel systems are failing and systems aren't meeting their needs. And the reality is systems are evolving in a very good way and maybe faster than what would have happened if we wouldn't have had a pandemic. And in, like what you've shared, I was so fascinated. And you're showing a video of your pool vac kind of working its way around and doing its thing. And I'm like, I'm just riveted. I'm on that thing. I'm like, holy smokes. Like he fixed that. I'm like, he fixed it for a couple of dollars.
Oh, pennies, really.
Pennies.
Yeah.
And what are the other applications? Maybe it's a garage door opener. Maybe it's a dishwasher. Maybe it's whatever, X, Y, Z.
Sure.
You could just think of these things
or like piece of plastic in the refrigerator. Like there's actually, my refrigerator has an issue, and I'm looking at the way it was designed, and it almost intentionally was designed so it wouldn't be serviceable. I'm like, can I 3D print a couple of parts in here so it snaps in, snaps out, so I don't have to make it so it's so awkward to service this one part on my refrigerator? And yeah, so I do look like, how can I make this easier for me, and possibly share it to other people that have the same issue.
That's cool. Yeah, my fridge is holding strong. It's my microwave that's turned on me. So
microwaves are cheap.
So as I shared, that every time I open the door, it starts up. So I've just decided it needs to be replaced. Yeah, because
and just remember, microwave radiation wavelength is really short. So even if you're only a few inches away from it, it's okay.
Okay, I didn't know that. So I was a little bit skeptical, and then I also was perplexed, Rich, honestly, like with how it would be designed to not just shut off. Like
that's crazy.
I'm like, so I went onto YouTube, right? And I'm like, what happened? And other people have had this issue. Like, here's the model, here's the thing, and like, here's how to deal with it. I'm like, I don't know, I've had it 10 years, and right, microwave is a very expensive thing, and for me to install a microwave that already has a plug in it, I just have to plug in the outlet above. It's not that big of a deal, but I stare at this thing. I'm like, why did you turn on the microwave?
I've never seen that. That would be
make a video of it before I swap it out, because it's just so perplexing. Like, I'm like, how would you?
I'm betting like maybe the fan's coming on and the lights are coming on, but I'm betting the microwave emitter isn't operating.
I don't know about that, because I think the whole thing is starting up. And kind of from the YouTube.
All right, so the test, put a shallow bowl in there with water, and that would be the test. And so microwave works by exciting the water molecules and getting them to vibrate, and that's how it heats things. And then the other part of it is its surface area in relation to the mass. So if you have a thin layer of water, it'll heat up very rapidly. So you can see the change in it quickly.
So this is the hand I used to put in my my Italian sausage dinners and stuff like that. If I'm grabbing for lunch, like, what could be the worst that could happen if this thing's in there for 3 seconds?
You get warm?
Yeah, I don't know. Could be bad, but I don't know. I think it's so. No, at this point, I mean, and I found some like tutorials, like you could order these parts or whatever. But and again, I guess, I mean, then I guess I'm relying on electronics. Apparently, it's a switch failure, is what people have identified. But I don't know. The whole unit though is kind of ready to be repaired. It kind of goes. We had a situation where I don't know what it was. Like it tried to microwave itself once about a year ago. Like we opened it up and there was all distorted stuff in the plastic and stuff. I'm like, it was trying to take its own life. So I should have at that time just sat down with it and said, "What's the outcome you want here? Do you want me to take you and to the recycling center? What's the deal?" So it tried to eliminate itself once. It's kind of like that movie Maximum Overdrive. Remember that where semis took over? I kind of felt my microwave was kind of taking on something like that. But so yeah, Rich, how can people find you and anybody here? Maybe either Vanessa or someone with a blue wrench. If you can post Rich's YouTube website, I'd appreciate that.
Sure.
How can people find you?
So youtube.com/flyingRich, Instagram is flyingRich_official. I'm on all sorts of other video sharing sites. So whether it's Odyssey or Utreon, so flyingRich over there. My flyingRich.com site is mostly broken, but the contact portion works. I'll have to fix it again.
Okay.
So yeah, and Instagram is real good for getting a hold of me. Unfortunately, for whatever reason, my phone app for Instagram doesn't want to post right now, so I have been posting content.
That is weird. I don't know what's going on.
I might have to reinstall the app.
Okay. Yeah, it's kind of like when I came up with, the image for this show was like the 3 gray dots, and I don't know why that happened. It happens once in a while and stuff like that. But I'm pretty sure, like when the show is done, like it'll just revert to the normal graphics that I.
Well, the link you shared in an email had the right graphics.
Right. It's because YouTube is against the safety doc, and it's because the safety doc has 1,150 followers, and yet only 1,700 view hours, which continually go down every day.
I think until you hit 100,000 subs, YouTube has no idea who you are.
Probably not. It is, and again, it's not the reason thank you, Robert. Thank you, Bolo. Vanessa and Bacon and everybody. I mean, thank you so much. These are, they follow the show and I appreciate that.
A lot of them, and I recognize a lot of the names out there, so I appreciate
Shelter in Paradise and doing, a little blog post out for people. And one of the things is just so people are aware of some things that they maybe weren't aware of before. So, right, if they're sitting around having a discussion on 3D printing, they're like, hey, like there was a discussion between flyingRich and Doc. And you know what? There's this whole open source community for 3D printing, and there's some other things. I want to look into this, and and why aren't we hearing about more of this? Or even like my kids' school, for example, my daughter, Rich, for Christmas gave me, and she was so excited. She said, "There's nothing like this in the world, Dad. This is just for you." She gave me a 3D printed business card holder. So it had my logo on it.
Cool.
And yeah, it was really cool. Like it's over on, a table, on the other side of the room here. And she was so proud of it. But yeah, so she's learning these things, how to enter.
Oh, that's it. And I'll tell you what, that's
school.
We always talk about technology and disruption, how Uber disrupted taxi cabs, and you can fill in the blank, how SpaceX disrupted, all of the big contractors for manufacturing spacecraft. And I think this is, I'm going to hit another Burt Rutan thing. I don't know if you realize this, but within 3 years of the Wright brothers making their first flight, there were over 2,000 aircraft in existence.
Whoa.
So the aha moment, I'm stealing all of this from Burt Rutan. The aha moment was these bicycle mechanics from Ohio built something that flew. I can do that. Burt was saying that with Spaceship One, that he wanted the aha moment to be that some crazy guy in Mojave built a spaceship that worked. Other people can do it. And maybe he actually succeeded in that. And I think that's the whole thing with 3D printing, is that when it becomes that crazy guy down the street is 3D printing fill in the blank, to when we're learning how to 3D print in school, that's when the cool stuff is going to happen, when people are going to be designing 3D printing stuff. So I just dropped a link in the chat for an Amazon affiliate link to me for a Ender 3 printer. So this is the Amazon's choice. $195 is an okay price. I would say if you click on that and look at it, maybe throw it in your cart and see what other links come up, because you might find a better price. So I would say $175 is a good price, but that was like pre-pandemic.
Right.
But under 200 is good. You might be able to find better.
Okay.
And
That's
guys,
amazing.
if anybody's going to buy a 3D printer and you have a question, hit me up on Instagram. I'm pretty responsive on that.
Okay. I mean, like, just as you said that, Rich, I mean, if someone was to ask me, what's the cost of a 3D printing setup? I'd say, I don't know, with software, everything, $1,200. And I mean, that's where I would have come off on that. I mean, I would have, when I worked at the School for the Blind, I was the director of therapy services, and we had a teacher, Tim, and this was like 3 years ago. He had a 3D printer, and he would print the surfaces of, like either, the moon or like the neighborhoods the kids would live in, right? He would print their things, and he'd be like, okay, so here's what the topographical map is of the community you live in. And it was amazing. So yeah, the kids would be like, okay, like I understand this and this and this and yeah. So I got to see kind of the early onset of 3D printing as it interfaced with people with visual disabilities, including visually impaired to blind. And Tim was phenomenal and plus he just knew this. It was his passion. And, so he's not out there printing, a 3D, like a spinner or something like that, more of a novelty item, right? He's actually printing so kids can navigate, and he had them navigate, distances and plot locations and XY axis, axis and stuff like this, all through this 3D printing. And I was just amazed. So I have no idea if I will put this up on eBay for auction, by the way. So this duck here, printed by the doc. So yeah, John's saying I didn't realize there was a sheep, but I just, you have to let me know. It's not prevalently shared in my home, so I don't know, but I might be willing to put this up. I made this. So just so you guys know, I did make that. And I also want to, in closing, just a little safety doc stuff here this is dun, 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 the most honest book about the $3 billion school safety industry, School of Errors, Rethinking School Safety in America. This is the book if you're a parent, right? You want to know what's happening for school safety in your school. If you're a teacher, if you're a taxpayer, hey, how are the dollars being spent on bollards and surveillance cameras, things like that? This is in hundreds of libraries across the world. Like every day I find out new libraries that have received this book. People email me about it, people on school boards. So it's been cool. And again, this is through a traditional publisher. I wrote this under contract, so you're not going to find spelling errors in it. It's very well put together, has a sewn, binding on it. So this is the first book I received back in 2019 when it came out. I use this when I present everywhere, Texas, all kinds of places, and the corners are still intact. It's really well made book. So, but the knowledge you're going to get from that, you can find it again. It's on places that sell books, right? But School of Airs, Rethinking School Safety in America, especially now as schools implement a lot of knee-jerk reaction policies. Well, a clear backpack, or we're going to put in more surveillance cameras or bollards or stuff like this. Like, really, if the book is going to, I was a school administrator. I wrote the book from my perspective. It's received, high reviews, right? You're going to understand what's happening. So if you have that discussion with your school district, or if your school board wants to, spend $400,000 on, 8K high def cameras to make your school safer, you can ask the questions and say, hey, like, have you done a inquiry or, evaluation of our two-way radio communications? Like, how is that working between schools or intra-school, like from one side of the school to the playground? And people are like, well, I don't know. We never tested it. So, School of Airs, Rethinking School Safety in America. It's a book I'm very proud of. It's a book that has been very meaningful. I've shared it with and was informed by parents who had their children were killed in school shootings, and said, this is a book that really talks about, the prevention side of things and how we need to think about inputting systems, right, and making them accessible to students. But yeah, so we're not spending all of this money on these crazy types of fortifications in schools that really don't make anybody safer. So my shout out just for School of, I know some of you have bought it. I know many of you have reviewed it, and I appreciate that. But it is kind of like a solo show right now. So hey, Vanessa, thank you. Yeah, yes, great book, great read. And I do have the new book coming out, Rich, the Velocity of Information, Rethinking, not the Velocity of Information, Human Thinking During Chaotic Times, is coming out April 11th. So as I shared with Rich today, I was working with my my publisher on the index. We finished that up today. So 3D printed bollards, believe it or not, that stuff is probably right around the corner. 3D printed bollards, stuff like that. So wow, just 3D print your bagel. My bagel is kind of a term I use in the first book of talking about how you get used to your daily routines. So Bolo, good to each other, be excellent. So all right, right here, 3D lettering. Okay, 3D print. Who knows? Yeah, this is amazing.
3D printing food, yeah.
Yeah, and I wrote about that in the Velocity of Information, where General Electric came out with a white paper a year ago and said they anticipate that they will be the source for many of your fast food restaurants, that they will have 3D printing of food within the next 5 years.
Well, why couldn't you 3D print a burger?
Right. And they said they're doing it right now in Germany, and they listed some other areas where it's already in practice, but that you would be able to do this. And not only that you'd have this burger, but let's say that you have a food allergy to, peanuts, or a milk allergy or whatever, that you would be able to enter your profile, and they would be able to make sure that the product was printed without the allergen in it. So, and I know that sounds kind of crazy, like, right, we hear all these things like, oh, I'm not going to eat bugs, and I'm not going to eat whatever, and things. And I'm like, the thing is, though, like, this is the whole thing of 3D printed food, I think has a really negative stigma about it. And I think 3D printed food is going to happen. I think there will be efficiencies built into it. I mean, just imagine if you could eliminate, fats from certain things that are printed, and you could build in nutrients and things like this. Now, again, I mean, people say, well, right, that you could have it controlled and have 3D printed vaccines into things and stuff like that. It's like, yeah, I get it, but it's amazing to think about kind of where these technologies are going, and I think 3D printing food could be a huge, again, self-sufficiency and just overall, nutritional quality and things like that. Like, I know there's so many people who would think about that and say, Doc, you're wrong, but I'm like, I don't know. I'm not willing to dismiss this. I think if it's done correctly, it can really be an asset.
And that goes to further automation. We already have kiosk ordering of the food, and if you have 3D printing of the food with limited manual, human interaction, that further increases the efficiency and cost effectiveness.
It does. Yeah. So I think these types of things are when I wrote about it in my book, I said there's always a default bias to change, and it's that it's bad. We want to retain our torus or our sense of similarity, and we will fight to do that. But eventually, like, we give in to the newer technology or the newer way to do things. And I mean, it was people, if you go back, it's like, people who were like, I'm not giving up my icebox, from 1930s and 40s in my house.
I was like, I'm not giving up my hardline phone.
I'm not giving up. Right. So how many, and today, if you were to, new home construction, I mean, you don't have hardline phone. You might have some Ethernet ports and stuff like that, but you don't have these things built in. So it is that, so it is something I stress in the book, and I'm excited. I guess I won't talk about too much now because I don't have a physical book to hold up and things like that. But it is April 11th. My new book releases, which literally, folks, is 3,000 hours worth of work on my part. And working, with my publisher, and I have graphics that designed for it. But the velocity of information, human thinking during chaotic times, and it's really, kind of what happened during 2020. It rips the bandage off of that. It's a very blunt book, but the interviews alone just carry it. And plus, the audio version coming out is phenomenal. I love it, and the fact that I have so many times I have to go through, the editor says proof this format or proof this or this index and things like. I'm like, I love it every time I get back into it. There's really nothing out there like it. So it's velocity of information, rethinking. Or not, if you go on anywhere right now. So now they've started to promote the book, and there is an AP press release which will come out, and things like that, and all those things. But the velocity of information. So yeah, I interviewed. There isn't any 3D printing in that book, but one of the questions I asked, like, Larry Lawton, America's biggest jewel thief, 1.5 million YouTube followers, and I asked, well, how'd you find out about 9/11? Because Larry spent like 7 years in the hole in a telephone booth, in a dark room in a prison. So how'd you find out about 9/11? Like, tell me about information in prisons and stuff like that. So just some really fascinating interviews. And then my research and, how things kind of come into it, but it's great. Who was interviewed? So yeah, I think, I don't know. I have to go through. The publisher already has quite a bit up on their website. So if you just type in the velocity of information, like, you'll have no problem finding like a description on my website, Safety PhD over here, my name. I've got the AP press release, the Associated Press release, which the publisher releases April 11th. That's already up on my website. So Larry Lawton, Linda Stone, who was the vice president of Microsoft, I interviewed her. And one of the things too, Linda was one of the first employees with Apple, like one of the first 10 people in the room. And the question, with Linda was like, she said, when we started the internet back in the 80s, like search engines, like, we were afraid if we return more than 10 results, people would be like, I'm done. I'm not ever searching the internet again. So imagine that, right? Today you think, you go on and you scroll, but the fear back then was information overload. So she talked about human attention. So she studied human attention. Phenomenal. I interviewed Robert Travis, the crab boater, who did 2 seasons. And one of the chapters, the title of the chapter is All of My Bosses Are Dead. All 4 bosses were killed on the deck. And he said, the job was so dangerous. Number 1 most dangerous job by the Bureau of Labor Statistics. He said a refrigerator-sized chunk of ice would fly over the deck and hit somebody and kill them. He said, it was. So you would sign on and you'd be maimed or killed. Like, this was the deal. And if you survived, you'd get like $65,000 for 3 or 4 months. But, and then, going through and interviewing Juan Brown, you guys might know Juan, he's a Channel 300,000. And Juan Brown is an airline pilot, also a private pilot. He flew over the Oroville Dam in 2017 when the water was rising and crested over the dam because the spillway had failed. So he lived downstream, and he's like, the media's not really covering this. So what's happening? And, hundreds of thousands of views. And it's fascinating because, we talk about journalism and it's hard to get in good information, but there were 3,000 people, Patreon supporters, who contributed just to have Juan do this. So, I mean, there's so many interviews in that. And these are hard to interview people. These are people I had to really earn their trust. Many phone calls back and forth. Everything had to be transcribed professionally back to them. And so so one of the assets of the book, right, is that you're going to hear from people that have not been interviewed by 10 other people. You're going to hear these really amazing stories, and how people interface with chaos during rapidly developing situations. So for me, it was super exciting to do that. Again, it was 18 months. I have visuals, I have diagrams that were constructed by a graphic artist who specifically worked with me. And I would sketch something. I'd be like, it's kind of like if I give it to Rich, to you, I'd be like, here, like 3D print this. And you'd be like, what is this? And this person put it together. And so anyway, I'm excited for that to come out. I don't think there's anything out there like it right now. If you're a Malcolm Gladwell fan or a John Ronson fan, it's kind of in those realms, or maybe a John Ronson. But yeah, my previous book, School of Errors, became a PBS special. So that in 2019 became a PBS TV special. So who knows? But I'm excited. I really am. And I don't know if everyone's like, hey, are you doing another book? I'm like, well, let me get this one out first. I mean, do you have any idea like what goes into a book and 471 endnotes and all this stuff? And I said, a nonfiction book is really an intense work to put out. But yeah, again, I wish I had something I could hold to show what the cover was and stuff like that. But so well, Rich, I want to thank you. One is I'm glad I got to meet you. We met kind of through John Crump Live. So shout out to John Crump and John's work. I appreciate his shows. I think John is really level, is really on point. So I think in the last year I've got to meet so many terrific people, and John Crump Live and John Crump.
Oh yeah, and John's been a big gateway to me for meeting very interesting people.
Oh God, he's really a good person. And so as I got to kind of meet you informally through John and then got to follow your work, I'm like, holy smokes, he's an amazing person, flyingRich. And then the more I learned about this and then, approaching you and your willingness to come on the show and to contribute this vast knowledge about 3D printing, and then also this interface of 3D printing and disaster and chaos, which nobody really has gone there. I don't think. I mean, at least I've researched this and no one is going there. So this is a show I will use as an archive to inform my knowledge and reference back to people. But you're tremendous. I love your shows. I love the content that you're doing, and just thank you so much. And I'm glad to get to know you as a friend through this whole process too. And it's funny because you'd be like, it's Florida, like it's this temperature. I'm like, it's -3 here. Like if I go,
it was cold when we started the show. It was 59 degrees out.
59 degrees. It's probably -7 here. It is miserable. Like if I just have to get my garbage can at the end of the road after it's been emptied out for the day, I have to jack it up and stuff like this because I'm like, cold. This sucks. I hate this. But in 3 months it kind of like goes away, and then Wisconsin gets better. But it is not good. So but yeah, thank you so much. And people, Marty and Ting Ting and Bacon, please follow Rich. And
a lot of these guys, we got a lot of common subscribers and viewers. So
okay, I appreciate that.
I appreciate it. Yeah, I appreciate it both ways.
So, Rich, I mean, thank you so much for being on the show tonight. I have a ton of respect for you. I look forward to just continuing to have you as a friend and as a, I guess, professional colleague as we talk about this. I know when I teach my course in fall, I want to touch base with you again and say, tell me more about 3D printing. Because, for example, school superintendents will say, we bought some 3D printers for our industrial arts lab, but I'm not sure what capabilities or things that are out there or crowdsourcing, and we can touch base on that, and I can share a little bit with that.
Oh yeah. I'll come up with ideas to pitch, because there's so many good things you can do.
So this is who is a Bish Egg saying you need to be 1 million plus. I think that's to Rich. I don't know if
is that to me or you?
Get there, but I am appreciative. I really enjoy. I've returned to podcasting. I had that 8-month hiatus when I was writing the book. When I said I was writing it, like I was intense, and now that I've returned, I really enjoy it, and I enjoy Faceability Friday. And I did last night. I spent about 2 hours putting together, the 4 articles we go through and things like that. And for me, it's just fun. And then I get to everybody in the chat who has different perspectives on things. And I said, face validity is really, I've just become so much better at that because of everybody. So, all right. Well, everybody, we are signing out for tonight. So I'm going to do this little bit of a celebration here for the show. So it's right here. It's coming off of this side. And everybody, thank you so much. This is the Safety Doc. It is a good friend, Flying Rich. Thank you.
Thank you.
MKJO. And take care, everybody.